And good morning, everybody. Sunday morning, everybody. Special stream day, everybody. If you're out there, let me hear it. Let me hear it, guys. That's right, we're going live, getting the stream set up. Got a bunch of stuff I have to send out. Oh my God, Jimmo, what's up, Jimmo? I didn't even see you there, Chipster. Make sure I got all this up and running. Good morning, Nemo. Good morning. Sorry, guys, I'm like 10 minutes late. Just a couple minutes late, but better late than never, right? I love coffee, guys. I'm gonna have to go get another cup of coffee before we get started today. I'm definitely gonna need another cup of coffee before we get started. Special stream day, guys. It is special stream day. Let's get it up and running, guys. We're getting booted up. We're letting the tubes warm up. We'll get started in a little bit, but until we get started, how's everyone's weekend going? How's your weekend going today, everybody? I gotta get my Twitter post out there right now. Gotta get the Twitter post out there, guys. Give me a moment. Okay. That's sent. That is sent out there. What's up, Pyro? You're punctual, buddy. You're punctual. I like it. I like it. Okay, I think I got most things set up here. Alright, I'm gonna send one more test message out. Make sure my bot is doing what it should be doing. It looks like it. Looks like it. Yes. Oh, I'm changing it. Don't worry, buddy. I'm in the mix of changing everything. Wait, did I spell that right? I did. I did! What's going on, Furzin? How's your weekend going, guys? How's the weekend going? Oh, excuse me, guys. Oh, so good. Sorry guys, I was looking at some websites here. Let's see what's going on here. Let's see what's going on here. First, you finished the pathfinding. Nice, nice. That can be triggered to block or free a path for stuff. Oh, nice, nice. Sounds like things are coming along nicely, Furzin. Anderson, you can finish your object loader today. This is good. Niffle, nice work, Niffle. Nice work, Niffle. Pyro, you're imagining things, Pyro. Sorry, Pyro, you're just imagining it. Never happened, man. Never happened. My coffee, I'm done with my coffee. Okay, sorry guys. A little distracted at the moment. But that's okay, we're just letting the stream warm it up. Diego, how's it going, man? How you doing, Diego? How you doing? You have 2 weeks for it? It's not a lot of time, man, not a lot of time. What's the plan, Jim? Jim, what's the plan for today? Jim, today we're going to have ourselves a conversation, my friend. We are going to have ourselves a conversation. And we're going to talk about a few fun things, buddy. We're going to be talking about a few fun things. What are we talking about? Oh my god, it's so early! We're going to be talking about optimizations around C#.net. Not just, and by the way, not just CPU optimizations, but also some memory optimizations. Because a lot of times memory optimizations lead to CPU optimizations in languages that do non-deterministic garbage collection, right? Right? Right. So I'm going to test something here, guys. For most of the stream today, I'm going to be switching back and forth between two different views. For a lot of stuff, I'm going to be switching into full screen view so that everyone can see exactly what's going on, nice and ginormously big. When I want to talk to chat, though, I will be switching back to my normal view here, which we can then have a nice little conversation. And for most of the stream, wow, I can't talk today, of course. I'll have music turned off as well. No music today, guys. Hello, Toxic. Excuse me. No divide and conquer today, Niffle. More specific, not, there's a couple things I'm going to talk about that are just computer science related. But most of the stuff I'm going over today are specific C# or .NET things. Probably not JDev. Ferguson, you chime in anytime you want, buddy. Oh my god, Cornflower Blue speaks. He shows up and speaks, guys. You know how it goes. Oh, this is the quietest song. I'll have music on and off throughout the stream. If we're taking a break, if we're hanging out, if we're talking, I'll have music on. But if otherwise, if I'm in full screen mode, music will probably be off. Will we talk about why tasks are faster than regular threads? Well, tasks themselves are actually not faster than regular threads. The only benefit tasks give you, because it comes from a task pool, right? Thread pool, which means the thread might already be warmed up. You might not have to create a whole new thread stack, right? But if you're doing your own thread pool for reusing a thread, it's going to be just as fast as a task. Yeah, JDev, sorry, man. Ludum Dares are cool. They're fun. But unfortunately, just too much work we got. Too much stuff we got to do every day to have fun. In that sense. What's up, James? Deflate in your chair and lurk. Oh my god. I like it, James. I like it. It's alright, Cornflower. I'll give you a hug later, buddy. I'll give you a hug later. Nipple, you should probably be taking notes. There's no handouts. I might post some stuff to a GitHub repository for a couple of utilities. But for the most part, you're probably going to want to take some notes if you're interested. Malapropos, there's always a VOD, man. Of course there's always a video. That's fine. That sounds good, James. That sounds good. Oh my god, Diego. Not much, buddy. Not much. We're just hanging out. We're hanging out a little bit, letting the stream kind of build up. I got to send out several Reddit posts. I got to put a few Reddit posts out there, guys. Let me go do that right now. Before we get started, of course. We'll see how today goes. Today's probably gonna be, you know, a little loose. It's not gonna be a standard. Don't think of today as you showed up to a class to learn something, right? It'll be a little more free-flowing, kind of like my normal stream is. But instead of me doing game development, we'll be talking about some specific topics around C# and .NET, and hopefully you learned something today. Hopefully you learned something. Give me a moment here, guys. I'm going to submit my first post. Alright, guys, if anyone out there is interested, here's a Reddit post. Feel free to upvote, downvote, comment, trash, delete. Do whatever you must do. Do whatever you must do. I support it all. So, Pyro, that is a problem. That's called context switching. I'll talk... Pyro, when we go live, I'll make a brief. I'll talk about that briefly, buddy. Oh my god, Douchebag Ganoush. How's it going, dude? How are you doing, man? We are taking a break from game development today, everybody. We're taking ourselves a little game development vacation. And instead, maybe I can impart some wacky, weird C# knowledge that I myself have learned over the many, many years of using .NET. Give me some. Learn to program. Learning program. I'm gonna put a post in here as well. Oops. Thanks for the follows, guys. Thank you so much for the follows. Got to get myself set up. No, don't go there. I'll be looking at chat here in a moment, guys. Let me just get these posts made. My Twitch Twitter tweet is sent out. Oh, man. Give me a moment, guys. I think this will do. Okay. And for my second act, here is my other Reddit post. Same spiel, my friend, same spiel. All right, let me close these down. Got to close up a couple of windows. Getting a little nuts over here. Getting a little nuts. Alright, what am I missing in chat? Can I do some Unity C# tutorials? Possibly. That is a possibility, Diego, on Side Project Saturday. Okay. Let's see what I'm missing in my other chat here. What's up, Skydiv Strike? Whoever wrote what, Furzid? Help with some schoolwork? Okay, Proton. Well, these .NET things work for C++ illies. Some of this stuff might extend to other languages, so I'm going to be mostly going through very specific C# .NET IL business. A couple things I'm going to talk about are general computer science optimizations, so those would definitely work. Totally should do help with homework Sundays. Homework Sundays, everybody. Okay. Use timers. Oh my god, Pyro. Oh my god, Azernus. Oh lord. Oh lord. Just sometimes, Furzin, I'm kind of at odds with the internet most of my life. Proton, have an array can be any size. Each index has a value. Using loops to find the value that repeats the most in the array. Oh my god, Proton. Am I helping you with your homework or your programming challenges? Oh god. What is the PST time right now? It is 7:30 in the morning, Ali Hammond. What is .NET specifically? God damn you, Anderson. I'm banning you from my channel for the day, Anderson. No apply. Nope, no apply. If you can figure it out, I will give you a cookie. You're writing a full-on custom Twitch bot, the toys? Ooh, nice. I'm assuming you're doing it in C#. I'm assuming. Don't worry, guys. We're just letting the stream kind of build up before I start. Obviously, my normal everyday stream, people can come in and come out and go and leave and stay and hang out and do whatever they would like to do. But today, you know, I would like as many people as possible to hear from the start, and if they decide to stay till the end, right? So we'll give people a little bit of time. And it's all right. We're here hanging out, seeing what's going on in chat. Sounds awesome, toys. Thanks for the follows out there, guys. So, Unity Coder Com, thank you so much for following. I do appreciate that. As I mentioned earlier, and yeah, a bunch of people are just coming in, for throughout the stream, I'm going to be switching in and out of my full screen mode that is on screen right now, between full screen mode and my normal mode. So when I want to talk to chat, when I want to interact with you guys, and I will obviously be interacting with you guys often because that's what I do on my stream all the time. But sometimes I'm not going to be interacting. I'm just going to be in full screen mode. I'm going to be explaining something, developing something, typing something, showing something, right? And in those cases, you won't see chat, but it will still be there in the background, and we'll always get back to it. Don't you worry about that. Everyone who is here is awesome. The most... Oh my god, Massey. What's up, Massey? Welcome to Niche Sunday. 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 We should go watch some monster truck rallies when I'm done today, guys. Anyone in? Who's with me? Monster Truck Sunday? No? Am I alone out there? You're awesome by proxy, James. James, you are not awesome by proxy. You're just awesome. No compression artifacts, Proton. That's why I'm going to be in full screen a lot today, right? I want you to see every pixel of every character. What is the microtext over the class program? Jim, this is, if you don't know, Visual Studio 2013. This is just some reference data, right? Visual Studio 2013 will embed this stuff in for you dynamically. This type has 0 references, blah, blah, blah. Tell you how often it's used and all that fun stuff. You got your RC monster truck, Gillies? I get that doesn't that doesn't count. That does not count. Is Top Gear? Come on, guys. Monster Truck Sundays? No? I'm alone out there, huh? Wow. Wow, no one wants to go see giant trucks smashing little cars. And then at the end, there's always the giant flaming robot that destroys other cars. Really? Nobody? You're hype, Skywill? I love it, dude. I love it. Massey, there is no roadmap for today, my friend. We will be off the... Well, I'm not off the cuff. I got some stuff prepared. But don't you worry, Massey. We'll just be going from topic to topic. We'll be jumping around a little bit, guys. I'll explain it when we get ready to start, Massey. There's no lesson plan, though. There's no lesson plan. There's no hard roadmap. Because what fun would that be for a live stream, Massey? When I'm here interacting with chat, if I just had a lesson plan and a roadmap, I would just disable chat, I would talk to my monitor for 4 hours and bore the hell out of everybody. And Furzin, I'm going to talk, the first thing we'll talk about, just briefly, even before we really start the stream, I'll talk about the topic you guys are going on about between tasks, full threads, the difference, sleeping a thread, and why that's good, why that's bad, and the proper way to do that stuff. Did you try 8 spaces in C#? It's really good. I have not tried 8 spaces in C#, sir. I have not. And yours is disabled. I love this feature, guys. It's a good feature. Why would anyone disable this feature? It's not in the way. It stays out of the way. Gives you relevant data at your fingertips, at your eyeballs. Oh, Pyro. So much love today, Pyro. Will your lesson material be available online later? Massey, for some of my stuff, you're definitely going to want to take notes. I mean, I can. Whatever we write today here, I could put this into my GitHub if everyone really, really wants it. I have a couple of things, libraries that I'll also putting up on the GitHub in a separate project for a few utilities. You might want to take some notes, though. No repo to follow at the moment, Diego. Because why spoil the surprise? Will this be on the test? I love you guys. Not Blizzard. Not Blizzard. Are you sure you're not Blizzard? I think you're trying to deflect, and you really are Blizzard. That will be had today. I know, Massey. I know, Mass. I think I'm going to have to go get another cup of coffee, and then I think we'll be just about time to start. Let me see. What's our time out here? Yep. Yep. Toys. So, because why could we have as simple as abstract? Toys, why don't you just go build an extension method to give that to you? And obviously there is the is keyword, which basically does that for you as well, right? And it looks like the silent sound. Yep, absolutely. That's the right idea. When will we continue the zombie dating sim? Callow, we do our zombie dating sim on our side project Saturday stream, which is every other Saturday. So we had it yesterday, so 2 weeks from yesterday. It's a possibility we might bring zombie dating back earlier than that. We've been thinking about that just to get a little more work done on it. So it's a possibility, but at the very least, it'll be back 2 weeks from yesterday. And you could do an extension method, and in your extension method, just use the is keyword in your extension method to do your evaluation, right? Oh, yeah, I see toys. You're using link. Okay, that's fine. That's fine. That's true, Ragathan, right? It's just it's testing for a specific specific implementation. It doesn't tell you if it's merely inherited. Absolutely. For that, just write an extension method. Do your test in the extension method. That's why awesome extension methods exist. How can I have multiple chats in only one window, Diego Coder? Because I'm kind of fun like that. Through the magic of programming, Diego. No, I have a chatbot sitting in both my Twitch and my live coding TV streams. It reads the chat and it just merges that locally onto my my OBS stream for me. Okay, guys, I'm going to be right back. I'm just going to grab another cup of coffee. I'm going to come back, and we're going to get ourselves started. All right, guys? So bear with me for a second. I think we've given everyone enough time to filter into the stream, so we're going to get started here. But I want another cup of coffee, damn it. So I'll be right back. I'll be right back, and I'll answer some questions. Give you a second. And I'm back, everybody. Oh my god, I got me a new cup of coffee. Somebody asked me, hold on, let's see. Somebody asked me, what was it? Master of chat windows, keeper of the bat hat, James. I know, I haven't worn the bat hat in a while, huh? What's my C# background? Wiseco, what is my C# background? That's an excellent question. Let's see, I've been using C#. I've been using C# professionally since the very first beta release of the 1.0 framework in, let me think, 2000? I think it was in 2000. Maybe it was 2001, but I want to say it was in 2000. Right around like end of 2000, early 2001, something like that. When the first beta release of .NET came out, maybe it was even a little before that. It's how long I've been using .NET for. Right? I've been using C++ longer than that even. And then professionally, I've been using a mix of both C++, .NET, C# for my entire career. So delicious. So delicious. In scale from 1 to 10, how much do you like coffee? This goes to 11, Toxic. This thing goes to 11, buddy. Using C# for your current project. Wistico, man, right on, dude. Welcome to the stream, buddy. Nice, Toys. Nice, nice. I like it. You can't say .NET for some reason. Sorry, guys. The bot. Moobot is a cranky bot. Moobot's a cranky bot. Why would I switch from C++ to C sharp? No ply. No ply. I didn't say I switched from C++ to C sharp. I said I use both C++ and C sharp. About 50-50-ish professionally for the last 15 years since C sharp came about. All right, everybody. Stream hopefully is not offline, Ali. Hopefully, you might have to refresh it, my friends. All right, guys. So before we actually get started with some stuff we were talking about, there was some chat. There was some talking chat. I was gonna say there was some chat and chat. I was about to say there was some chat and chat earlier, but there was some talking chat earlier about why you should use tasks versus threads, right? And for instance, if we have a thread. Right, thread, new thread. We can give this an anonymous lambda, right? Anonymous function. What is the difference between using this? What's the difference between using this and using this, right? And this is not what we're really going to be talking about today, but it's appropriate enough. It's appropriate enough. And I'll talk about a few more things around this as well before we really get started today, right? What's the difference between using this and using this? Well, there's really only one difference between using a thread and using a task, right? A task is backed by a thread pool of real threads, right? So behind this factory is just a collection of they're not really pre-initialized threads. It will spin them up as they're needed if there's not enough. But ultimately, guys, this is exactly the same performance once it's warmed up, right? Tasks are backed by full-on threads. There's really no such thing as a light thread. There's the concept of coroutines in C sharp, and maybe we'll talk about those today. But there is threads, and tasks are just a way into the thread pool that's really always existed in .NET. They've just, in 3.0, they made it much easier to use the thread pool with the tasks, right, with the task API. So a thread and a task ultimately are the exact same thing. It's just if you create a new thread every time you want to use one, there is a lot of overhead in the initialization, the boot up time of that thread, right? Because every thread has a stack size. It has to create its context, right? So there's a lot of warm-up time, if we want to call it, around a thread. Whereas a task, once you're done using a task, there's a pool of thread objects that are just sitting idly in the background that the task factory is going to say, hey, here's one not being used. Let's just use it. Give yourself a new context, new function, new code to execute, and just execute it, right? So you save all of that cold boot time, right? So it's just a way to warm up a bunch of threads and to reuse them for whatever you want, right? So that's the only difference really between a thread, between a thread and a task. No, another Mormon. I sure hope threads are not considered advanced programming techniques. This is somebody just asked, before we get started on stuff, somebody just asked about threads, about tasks. The other question was, should you use sleep, right? Should we use sleep to communicate between threads, right? So if we use thread dot sleep, I can't type. Why would you want to use this, right? What's the deal with using a thread sleep and in fun business like this? Well, whenever you use a thread sleep, guys, it's all about context switching. When you go back to the kernel, ultimately the operating system can only run one task per core. I know that's a very simplified view of what the CPU is actually doing, but we can only run one task per core at a time, right? So the OS has to time slice all of your tasks, all of your threads, appropriately. So whenever you're using a bunch of threads and you're trying to swap between a bunch of threads, and if you have more threads than you have cores, then you're going to have to start getting into what we call context switching. Context switching is very, very expensive, and context switching is basically saying I have 30 threads, I have 2 cores, I can only run 2 time slices at a time, but I have 30 time slices that need to run at a time. I have to keep switching in and out of contexts in the kernel to get between all of these threads, right? So when you do context switching, it's a very expensive operation. You want to try and keep in one context for as long as possible, right? Because if you're constantly going in and out of 30 or 100 threads in a very short amount of time, you're going to have a huge bottleneck in just context switches, right? So you want to try and reduce all of that into as few context switches as possible. So that's kind of when we talk about threading is not simple programming. Writing multi-threaded applications is not easy. That's one of the considerations you have to think about when you do multi-threaded applications. Is sure you could throw as many threads at the problem as you want. Sometimes throwing more threads reduces performance and does not increase it because of context switching, right? Somebody else asked, how do we keep threads around when they're not doing work or waiting for work to happen? And that's where somebody mentioned that you can use thread sleep. That's not the way to do it, guys. Don't use thread sleep. Use semaphores, use mutexes, right? Instead, tasks make this easy, right? Because tasks have a wait, which you can get in to have a timeout. Or you can have a cancellation token to see if it got canceled. Use waits, guys. Use your waits, right? Use that. Because then you can use signals. You can use signals between your threads to say, hey, my thread operation is done. Let me signal that I'm done. Anybody else that's waiting on that signal, it's much more optimized than using a thread sleep. Because if you just do something like this, right, while not done. Oh, sorry, let me make this a little easier. While other thread not done, thread.sleep 10 milliseconds, right? You're now going to spin. You're going to have to context switch back into this thread every 10 milliseconds to check on if the other thread is done. This is right back to what we were talking about, right? Context switching is very expensive. Instead, the kernel gives you a much easier way to do this with using wait, right? So instead of doing this, you could rewrite this if you had a task. If you had a task, you can say task.wait. Your code will now block, just like it was in this while loop, until you get a signal from that other task that its job is done, right? And you can use signals for anything you want. They don't even have to be used in multi-threaded programming. You can use them for however you want, right? So now this will go into the kernel. It'll be flagged in the kernel. You'll not context switch constantly in and out of this thread, waiting for the other thread to be done. As soon as it is done, you will get signaled into the kernel, and it'll wake this thread back up and continue on, right? So somebody who said you should use timers or you should use sleep, don't do any of that, guys. That's really, really bad. Use what's available to you. Optimize it. Okay, guys. Back to looking at chat now. Diego, what's the difference between Task Factory Start New and Task.Run? Nothing. Nothing. Just when I usually like to hit the Task Factory because sometimes in our software development we might implement our own Task Factory. So it's always good just to have it in there in case we want to replace it. All right. My coffee's almost done again. So when would you use threads or tasks? Not Blizzard. As I said earlier, threads and tasks are exactly the same thing if you are using your own thread pool. If you just want to start up a thread to do a small block of work as a fire and forget type of operation, use a task, let it go to the default thread pool. If you're going to use a background thread to keep it alive for the entire length of your program, to do some type of weird work. Maybe you have a background render thread, maybe you have a background job reader, I don't know what it is. But if you have a background thread that's going to operate for an extremely long time or for the entire length of your program, spin up a dedicated thread for that, and that's fine. Tasks are for fire and forget, quick operations, because if you put a lot of long-running jobs as tasks into the task worker pool, you're going to tie up threads in the thread pool. Oops. Anyway, guys. All right, that's enough talk about tasks and threads, yeah? If you have no other thread to wake the waiting thread, is there no difference between sleep and wait? There is still a difference, Wiseco, right? Because while your thread might be in a sleep or wait, remember, we work in multi-tenant operating systems, right? There are other applications running on the operating system. Your application does not get 100% of the CPU time. The OS is going to time slice not just your threads, but every thread across the entire operating system. Limited, yeah, absolutely, guys. Write your own factories if you need them. Keep the coffee flowing, Mason. Yes. All right, time to get started, everybody. As I said earlier, I'm going to be going in and out of my full screen mode and back to my default mode with chat as I want to talk to chat. As I want to interact with you guys, we'll definitely have chat up a lot. Don't worry. But a lot of time, I'm just going to go and keep full screen up so you have a better view. Hopefully, it's not as artifact ridden or artifact laden as it normally is. Oh, niffles. Oh, niffles. How about coroutines? Ollyhammer, coroutines are not threads, right? Coroutines are not threads. Coroutines are, coroutines are implemented in C# using the yield keyword around, is it IEnumerable? I always forget. I think it's around IEnumerable, right? But coroutines, and how they implement coroutines in C# is if you use IEnumerable, and if you have a yield keyword in your function, the compiler is going to spit out a state machine for that function. So old school. All right, guys, let me pull a few things up. All right, what are we going to talk about first? What do I want to talk about first before we kind of just get into some other advanced topics, right? And some topics are going to be more advanced than others. Hopefully, you already understand C# out there, guys. I'm not going to be explaining how to develop in C#, what C# is, how to write C# code. I expect you guys already know how to do most of that. The first thing, and I think this is not just a C# or .NET thing, guys. If you're writing C++ code, if you're writing Visual Basic code, if you're writing C# code, if you're writing any software out there, it's extremely important to understand what the compiler is doing to your software. I believe it's very important to understand what the compiler is doing to your software when you compile it. Because if you understand what the compiler is doing to your code, you can write better code to get better compiler output, right? And .NET is no different than doing it in C++. When we do that in C++, obviously we compile our code. When we go and inspect the assembly, hopefully you can read assembly if you're developing C++ code and you want to get to that level of optimization. And I'm not saying you should go write assembly. I'm just saying you should understand how the compiler is optimizing your software to see what it's doing, right? So that you can go write better code to get better optimized software. And .NET does the exact same thing when we compile our C# application. If you compile any .NET application, the compilation step is going to compile it to Microsoft Intermediate Language. It's a very ASM-like language, right? It's just an opcode written language, saved out to a byte code. And then obviously when you go and run your software, it's going to get JIT. It's going to get compiled on the fly, optimized on the fly into machine code when you run it, right? But before you get to that step, it's in IL, and the IL can be optimized or can be unoptimized. But it's always important to understand how your compiler runs. So if you already don't know this, and this is not a very advanced topic exactly, but if you don't know this, it's very easy to go look at how your IL is generated from your software. If you just go into your tools and we go create a little tool. We're going to go create a little tool. And this is because I haven't built this yet. Let me go build it real quick. Once you at least build your software once, right, we can then go inspect the IL of your software. I'll show you how to set this tool up. It's very simple to do. But inspecting your IL is very, very easy to do once you set up a nice little tool in Visual Studio for it, right? So we can look at our constructor. We can see what our constructor does. Obviously, right now, it does nothing except construct, right? We just call an object. What constructor are we looking at here? We're looking at our constructor, right, which we're not actually in. This is behind the scenes from us because we don't implement a default constructor. If we look at our main, and we're in debug mode, and I'll talk about the difference between debug and release mode, IL. But we are in our entry point, right? This just tells the runtime. This is our entry point method. It's our main method. It's all fine. There's really nothing going on. We have just a no op and a return. And why do we have no ops in here? Because we're in debug mode. No ops get scattered throughout your IL for debug purposes. If we do a release mode, which I'll show you in a second, no ops will go away, right? No ops don't do anything, but you don't want them in your IL and release mode because it's a small performance hit just for the jitter to throw away no ops. But to set this tool up, little tool up, you just want to go to external tools. And I'll just put this on screen if anyone feels they want to copy this. You can just add a new tool. I call it ILDASM because that's the name of the program. You just got to go find your Microsoft SDK folder in your Windows. Just go find wherever your SDK is installed. It's going to be there, trust me. You can also just search somewhere where you ever have ILDASM.exe. That's all we're looking for. We're using the .NET 4.0 tool set for this. Find your ILDASM. Pass in an argument for target path, and that'll give you a nice, easy external tool that you can run against your project that's compiled to see the assembly. It's very good for just inspecting what's going on. Very good for inspecting what's going on. Raven Dole, it's fine if you're a newbie, my friend. Hopefully you learned something. So ILDASM, everybody. I'm just giving everyone a minute here. Set up ILDASM if they so choose as well. I love me some ILDASM, guys. This is probably one of the most used .NET tools I use day in and day out. So ILDASM, right? So we have some software. This does nothing. What if we wrote this to do something, right? Console. Right line. I love my little Hello World apps. Your very basic first C# app you probably wrote. Little Hello World, right? We'll go and compile that. Once we compile it, we can go look at our ILDASM. And we go find our main method. And now, instead of this just being a no op and a return, we actually finally have some IL code, right? And this looks, while this is not assembly, it's not too far off from what you would see in ASM or x86 assembly. Very, very easy. We're just loading a string. It's a const string, right? Because we're not storing it as a variable. It's not dynamic data. It's a const string. It gets interned. We'll talk about interning. And then from there, we just call an argument, right? So this is loading this on the stack. We're calling this function. This function only has one argument on the stack, so it's going to pop this off the stack. This won't be on the stack anymore. And there we go, right? So we're going to call console string. There's nothing else on the stack. Our stack is 0, so we're free to return. Everything's great. If there was something on the stack and we called return, it would return the first item on the stack, and that's how you return variables, right? Very similar to assembly. Very similar to assembly. Okay. So that's how we can get into some assembly, and we're going to be using that a little bit today. I just want to make sure it's clear what IL is, how we can go look at it, because it's kind of important, right? All right, first topic of the day, guys. First topic of the day. First topic we want to talk about. I want to talk about object allocation in .NET. Specifically around generic types or unknown types to you. And this is in cases of plugins. This is if you have generic factory systems that you don't know what the type is up front, right? Obviously, if you're just doing, var or object O equals new object, this is as fast as you're ever going to be able to get for newing up, for initializing or allocating a new object, calling its constructor, right? It's not going to get any faster than this. There's no trick that makes this any faster. There are some tricks we'll talk about related to this later. But if we have to allocate, if we have to create a new object, this is the fastest way to make this happen, right? But what happens if we don't know what object is, right? We have a static void create that takes in, it could take in anything we want, type, right? Assume this is some type of weird factory, maybe taking a string, maybe taking an enum, Maybe you're reading a type from file because you're using some type of version of control or dependency injection. There's all types of reasons, or you're using a plugin system. There's all types of reasons why you might not know exactly or have a function that you need to new up an object and you don't know the type explicitly, right? Or you might see a lot of code like this in inversion of control situations, right, where they have a generic, which takes in a type, right? So now T, we can pass in T for a type. And there's different ways you can new up this T, right? We could just say return new of T, as long as we give this where T new, right? Sorry, hold on. Email people bugging me too much. Sorry, okay. So now we should be able to return a new T. This is a void, let's make that T, right? And this will be correct. Let's take a few little tries here. Oops. We can also have static object create return new object, right? Right. Let's see, create native. We'll call it that, right? We have to give this different names, otherwise it doesn't really know what it's doing. And then we should be fine, as long as we do this correctly. So now we have two functions. We have a create, which takes in a generic creator, which you can pass a type, right? So we can go var o equals new. Oh, sorry, not new. Create native, or we can do o equals create of object, right? Everybody understands generics. Now, syntax-wise, operational-wise, these are exactly the same functions. We're going to new up an object. We're going to new up a type, which we're going to pass in as a generic of an object. Let me switch back to chat here for a second. And we're going to try and take things kind of slow today, guys. We're going to take things kind of slow. So hopefully you're along for the slow ride, because I want to make sure people understand what we're talking about. And I'm going to switch back to chat. Not that. I'm going to switch back to chat. Who out here, what do you guys think is going to happen? We have a native, right? We have just new object. Here, this is exactly the same. It's a generic type. What do you think is going to happen? Do you think we're going to have the exact same object allocation time? Is a new of a generic type and a new of an explicit type? Is this going to be the same opcodes? Is this going to be the same performance? Is this going to be faster, or is this going to be faster? Let's hear it in chat. I'm just curious. What do you guys think is a better approach to doing this? And Diego, why do you need inspect IL? We're going to get into that in a moment. Let's see what you guys think. Wiseco, same speed. Cool. Okay. Same speed. Different opcodes. Of course, it's going to be different opcodes, more than likely, right? But same speed. All right. Ramses thinks the generic's going to be slower. You have no strong feelings one way or the other, James? I love it. CaliQ, what does this do? This explicitly lets us know that you can new up T, right? If I take this off, while normally this will not work, right? Sorry, let me take this completely off. We don't know that T is a newable type, because T could be a struct, T could be a value type. We don't know what it is, so this would not compile. We have to give it a hint. We got to give it a constraint on the generic that says T, only types of T that implement new can be used. Lady Subu, I'm going to be here all day, man. You know it. Alright, so Cornflower thinks they're going to compile to the exact same thing on release mode. All right, the compiler's optimizing. Well, let's do this, guys. Let's take a look at a release mode IL. We can look at the IL, right? We don't have to guess. We can go look exactly what the heck's going on here. All right, let's go look, guys. I love it. Everyone's got their opinions. I love hearing that, guys. We just built this. Let's run it. Make sure it doesn't crash. Obviously, we have proper code, right? And then let's go look at IL Dazzle. Let's go see what the heck is going on here. So we have two create methods, guys. We have two create methods, right? We have a create native, and if we look at the IL for this, this should look exactly how I would expect it to look. All we're doing is a new object of type object, and this is the constructor that the new object operator should use, right? The default constructor. And new object will put that new object instance onto the stack, and now we're going to return. And since we're returning and there is an object, there's an item on the stack, so we're going to return that item, right? So create a new object, return this new object. Two IL lines, right? Two opcodes. Two opcodes. All right, here we go, guys. Here is our generic create. Here's our generic create. Whole bunch of IO going on now, right? Oh my God, there's even some boxing going on. No good, no good, no good. So this has two locals that it has to initialize, and these are for tokens because T is a token, and that's just how generics work in IL, which is fine. We have to initialize the object. We have to then load it onto the stack. We have to box this freaking thing. We have to then do a check. And why are we doing this? Because we don't know what T is. We don't know if T is a struct. We don't know if T is an object, right? We don't know if it's from a value type or from a struct, basically, or from a reference type, because it could be either. It could be either. So it then has to load all this up just to do a check, to say, hey, are we an object type or are we a value type? If this is false, we're going to go all the way to 1A, which is say, okay, let me new this up, and we'll talk about this in a second. Let's go and new this bad boy up. Otherwise, we just call a init object on it, because that's how you create structs. It's an init object call, not a new object call, and then we're going to return it, right? So that's fine. However, if it is an object call, why aren't we calling new object? Why aren't we calling new object? Well, we can't call new object. We don't know what T is, right? We don't know what T is. Instead, what it's going to do is use the activator.createInstance, which is a reflective API call that says create an instance of a type. And when this is the tokenized version of the type of what we're trying to use, right? So that's what this comes from. So that's what it is. We're going to get a create instance, and then we're going to return that. But still, looking at this IL code, we don't know if it's going to be slower or faster, right? We don't know what's going to still be faster. Now, obviously, this is more IL code, so we could probably guess, and this is release mode, by the way. This is not debug mode. We could probably guess that this is going to be slower. How much slower is it going to be, though? Because that's what matters, right? So just looking at IL doesn't tell us that, is this going to be 5 times slower? Is it going to be 2 times slower? Is it going to be 0.5% slower? Because if it's just that much slower, we don't care, right? If it's that much slower, it's not that big a deal. Not that big a deal. So what we need to do is go write some measurement code for ourselves so that we can do that. So I'm just going to copy and paste a little code in here that I wrote earlier, only because, I'm lazy. Just a little lazy, but it's good for us. And we'll explain what I'm copying and pasting here, guys. Don't worry. Don't worry, because we're going to be using this all day today. So I just wrote a little measure function. It's a little test function for us. Let me get stopwatch in here. So what does this do? This takes in a string what. This is just for outputting so we know what we're measuring. How many repetitions should we measure our action? And then we're going to get averages, min, and max around that, right? We take in an action, which is basically just give me a anonymous function to run, right? So we're going to warm it up. Why do we warm it up? Well, because remember in .NET, we compile the IL. The first time you execute a function, the jitter is going to have to go and jit that function and everything around it. So the first time you execute a function is always very slow when we're trying to do measures, right? So in .NET, when you're doing any type of measurement, make sure you always warm up your code. So we do a little warm up on it, just make sure it gets jitted. And then this is very simple code, very simple measurement code, right? We're just going to go through our reps. We're going to use a stopwatch to measure how long each action takes. This is not super scientific, guys, but it's good enough for what we want to do. So once we have all of this data into a double array, right, we can then use some link stuff that gives us min and max and average and all that fun business, because that's all we care about. We just want to measure how long each action takes in our repetitions, and then we can get averaging out, right? So we have a measurement function. We've gone and written these two functions, so why don't we just go measure these and see what's going on, right? So reps 5, let's see, how many iterations do we want to do, right? So reputations, and I'll show you why we do iterations as well. It is, we'll say 10,000. Let's do 100,000 iterations. For something like this, we want to stress it out so we can actually extract out some needful data, right? And then we can call our measure function now. This is create native. No problem. Reps. And we're going to create a lambda, just a little anonymous function, to do what we want. And for here, for int I equals 0, I less than iterations, plus I. We want to stress out create native, right? That's all we want to do, and this will measure our native function. Now we can come in here and we can do a create of object. And we can measure this as well, right? Give me a moment. Oops. Okay, let me get my chat back up. We can see what's going on. Here we go, guys. Let's see what we're doing. So, let me change our name. Create generic. What is our crazy differences here? So, on average, this is every call, by the way, and this is in milliseconds. On average, our native create function is 0.4 milliseconds. On average, our create generic is 12 milliseconds, guys. Now, I know we're looking at this and we're saying 12 milliseconds, that's nothing. 12 milliseconds is actually not nothing, depending on your use case. Now, obviously, if you don't create a lot of objects or you don't create a lot of dynamic objects at runtime, if you don't know, again, this is about not knowing the type at compile time, right? Sometimes you don't know the type at compile time for various reasons. Maybe we have a scripting system that dynamically can create objects and we don't know what that object type is off the key, right? So there's a lot of reasons why we might need to create objects generically. And that's a pretty big difference. Pretty big difference. Ubi. Same operations with the same number. The compiler checks that actually don't execute. Nope. Nope, not at all, Ubi, not at all. C# does not check that. So, right, guys. Now, remember, .NET, we're newing up objects. We have to be a little careful. Garbage collection is kind of kicking in on us here as well every once in a while. And if to prove this out, say, all right, maybe this is a garbage collection problem. We could fix this. Let's go make sure our test is still correct, right? And if we do our generic first and we do native second, we still have a huge problem. To be doubly sure, we're going to go and run a collect. We're going to do a GC wait for pending finalizers and collect again. Do a full collection process here. We'll move generic. Do this. Oops. Give me a second here, guys. So we'll try and take out the garbage collection noise, right? Because there could be a little noise coming from the garbage collection between these test runs. Let's run that again. Let's see what the heck's going on. We still can see that there's a pretty major problem, right? 10 milliseconds versus half a millisecond. Pretty damn huge, guys. Pretty damn huge. And here's the thing. This type of code is not uncommon. This type of code is not uncommon, right? If you look at frameworks all over the place, you will see this type of usage all over the place, guys. All freaking over the place. Now, I'm not done. There's other ways we could go about doing this. This works. This only works in a generic sense if we know the type, again, if we know the type at compile time, right? We still need to know what the type is at compile time, and we want to generically create it, because since this is a generic. There's another create possibility where we pass back object. We'll take in a create. We'll call this create reflect, which passes in a type. Right. So there's also create scenarios where we have the native. This one's fine. We understand this. This is a scenario where you're going to pass in a generic. You're going to pass in the type as a generic, which means it's in at compile time somewhere. You know what that type is. Otherwise, you can't call that generic like that, right? There's another scenario, and this is more of a inversion of control dependency injection type system. Say you have a config file, and in the config file, you want to dynamically set which object type it should use at load time. We do this in video games a lot for data-driven operations. Or in a scripting language, you don't know what the type is, right? You need to reflect, you need to inflect the type. Sometimes you might pass in a string. You might pass in a string or an enum, all right? Enum object type, whatever that enum might be. And then from that enumerator, you do a switch case through it. Say, here's this object type. There's lots of ways you could do this, but sometimes we need to go full-on reflection, and we don't know at the generic time what the type is. We need to be able to pass in a type or pass in a string that can look up the type reflectively for us. But let's assume we just have a type, right? There is a .NET gives us a mechanism to create a new instance based off of a type. And we kind of saw that in the IL, right? We saw that in the IL in our code, which makes things a little easier. Which is fine. This is going to return using the activator create instance. My brain's not working yet today. And this is where you can pass in type, right? So then we can just return that type, right? Oops. So now this is the reflective way. This is how you use reflection. And ultimately, by the way, this is using the same thing here. It's just looking up the type for us. This is just some syntax sugar basically around this for us, right? But here is us directly calling and say, all right, well, if I just pass in the type directly and I use an activator create instance on it, this is doing the same thing. Let's go see what the performance looks like when we use this. All right, so we have create generic. We have a little test case here. Let's do this again. Create. I can't spell create today, apparently. Reflective. And then this is just going to create. Reflect. Let's see what happens before we get to our issue, right? Oh, and to take out the type lookup, cost, because we don't care about that in our test here, right? We'll say type. Object type is equal to type of object, right? So we'll pass that in. We don't want to do this type of lookup. This is pretty fast. It's not that big of a deal, but we don't want that muddling up our test results. Let's see what we get here, guys. Let's see what we get here. Well, what do you know? While we're at about 10 milliseconds on average for generic, reflect is a little faster, guys. Reflect is a little faster than our original code. Did anyone expect this? Did anybody expect this? That our reflective object create would be faster than using our generic? Did anybody see this happening? Did I blow some minds? I don't think I blew that many minds. And why is this going on, guys? Very simple reason. Let's go look at the IL again, right? Remember, always check your IL for performance stuff like this. Let's go back. Let's take a look at what create reflect does. Create reflect, very simple IL that we're loading our arg, which is the first argument into the function, which is a type. Then we're just calling activator create instance for that type and returning it, right? Three ops, that's it. Let's go back. Let's take a look at what our generic create does. Our generic recreate has to do a whole bunch of stuff, right? You got to check, is it a struct type? Is it a value type, or is it a reference type? And depending on what it is, ultimately though, it's coming back to that activator create instance for the type, right? So ultimately it's calling back into here, but there's so much more boot up code to make that happen. And this comes down to, unfortunately, guys, unlike C++, unlike templates in C++, templates in C++, the code generated in C++ for templates does not have any of this weird boot up code around templates, around templated arguments, right? They bake in a whole new class around that type. C#, however, or .NET, when it uses generics, doesn't do that. It has to emit IL to kind of make some of this happen. And remember, guys, we're going to get slightly different results every time you run this because of garbage collection. So you make sure you have enough test stressing going on, getting enough averaging, run this a few times to see what you get. But on general, we can see about 10 milliseconds for generic. We shave off 3 milliseconds. We can shave off 3 milliseconds when we use reflect. And this is our baseline, right? Create native is our baseline. Still, though, guys, still, this is still not fast enough. We can get even faster, everybody. We're going to go faster and faster. And how the heck are we going to go faster? Well, my friends, I'm going to switch chat up because for a few minutes, we're going to go write some code, and I'll get chat back in here. But for the moment, let's switch away from chat. Let's talk about how can we go fix this problem. By the way, if this is even a problem you need to fix, right? This is not necessarily a performance issue in every C# application. This is a very specific optimization that we're talking about. And sometimes we get to those places where we need to do these type of specific optimizations. But not in every case is this a problem. Just so everyone is clear, right? How are we going to do this, guys? How are we going to do this? All right, so to make this happen, I'm going to go create a new class. And we're going to call this a fast object allocator. We're going to create a new class to make this happen. And I'll explain why we're wrapping this as a class, not just a function somewhere. We want to make this a public static class. We're going to use generics here, by the way. Generics aren't bad. I know I just said, hey, be careful with generics, but generics aren't bad. Even though we're going to create a fast object allocator around that use case where we can pass in a generic type. By the way, you can also, what I'm going to write, you can also rewrite to take in a type instead of passing in the type as a generic, right? Instead of templating it, you could pass in a type and still make this work. It's just a little bit, the code probably is going to be a little different. And we will only want to do this on types where T is newable, just like you saw earlier. Oops. Okay, so we're going to create up a bunch of static data to make this happen, right? So what am I going to do, guys? What are we going to do? Well, we looked at IL. We saw how IL works in on our very optimized case. In our create native, it's just a new object with a default constructor, or the constructor that you want, and a return, right? It's two IL operations. Well, guess what, guys? Just like in C++, we could emit our own IL and bake it into our process at runtime and then use it. That's what we're going to go do, guys. We're going to go build our own newable delegate, and we'll see how fast that is, right? So this is what I talk about when you get to some really advanced C# stuff. Not very often do you see a lot of C# or a lot of .NET developers writing IL themselves, and especially not writing IL based around input parameters and specializing it, and we're going to get into that. So I just want to create a delegate, right? So this is just how I want to create a delegate type of a funct for a type, because this is, if you know what func does, right, if we look at the IntelliSense, this is our result, right, our return value is that type, because we're going to be creating a new object of that type. So I just want to create a function that returns T. Call it M object creator. And we'll initialize it to null at first, right? Because it's static. I want it null. We're going to lazy load this. And I'll talk about what .NET does around static classes of generic templated types. Okay. Let's go write this little sucker. It's really, really not hard to write this, which is great. So we'll call this just new. We don't need to template it here because since our class is templated, we can use T wherever we want, right? And we're going to return T, which is awesome. First thing we just want to do is check if this object creator is null. Because when I talk about we're going to lazy load this, this is what I mean by lazy load, right? We initialize it to null. We're going to create it. We will go and create this on the fly. Now, I could optimize this even further by creating a static constructor, and maybe we'll refactor this in a second. Using a static constructor, initializing mObject creator ahead of time, and we'll save this branch check, right? Because this is a conditional check that we're going to have to make every time we want a new. But let's do this first, and we'll see if we can then optimize it away. Maybe it'll get a little faster, right? So we just want to get the type is equal to, instead of using var, I know I get bad with using that sometimes, I'll spell out exactly what we're looking for. Object type is type of T. We need this. This is important. We need to know what the type is. But we're only doing this lookup once. Remember, we only do this lookup once because we're going to set object creator. All right, so now I got to use a little bit of reflection, everybody. I got to use a little bit of reflection to go look up the default constructor. And you could rewrite this if you want. Say you don't want to just use default constructors. Maybe you want to use constructors that can take a parameter, or 2 parameters, 3 parameters. You can write this however you want. For now, for our test case here, for what I'm just trying to teach you guys, we're going to use default constructors or parameterless constructors, right? From our object type, I can get the constructor. This is reflective work here. And I want to say new type. Built-in array, right? Just an empty array, which says, hey, go give me your parameterless constructor, which is oftentimes the default constructor, right? And this returns a type of constructor info. And we'll call this our default CTOR, default constructor, right? We need to add in reflection. Namespace. Excellent. All right, so now we have the type. We now have the default constructor. Let's go generate the IL. Let's go create a method and embed our IL. And how we do that, and this is very, very nice in .NET now, because we can create what we call dynamic methods. And dynamic methods can get destroyed. The old way of emitting IL in .NET, you would have to go build a dynamic assembly. It would have to get written to disk. It would get compiled to disk. It can then get loaded back into memory, and it stays in memory for the life of that app domain. But now in the world of new .NET, this has been in here for a long time now. We have dynamic methods, which is great, right? So dyna method for now is equal to a new dynamic method. And what does a dynamic method take in? We give it a dynamic method. Is not a class. Basically, a dynamic method, think of it as a static function, a static public function that's free-floating. It gets baked into an internal assembly, an internal class, but we don't care about that kind of business, right? And let's add our constructors. We just need a few things. We need to give it a name. This is the class name. We don't want this to collide with anything else in the system since we're dynamically creating this stuff. I'm just going to bake in a way to make this generic, right? So we're just going to create a GUID, new GUID. So basically, we're going to get a function name of underscore GUID. Oops. I just want a function name of a GUID, right? So we're creating a random function name. But we don't care about the function name. We're going to have a delegate to use this. The function name is to make sure there's no clash. There's no namespace clash. The return type is our object type, right? So this is a method. This method has a return type, and it's type of T, right? So that's why we look up T. And then it has parameter types. In this case, it has none. If you want to rewrite this to support parameters, you would just have to pass in the types as a list, or as an array of the types. But that's fine. We don't care about that for now. So here we go. We have a dynamic method. All right, how can we go use this dynamic method? Well, that's what IL generators are for, guys. We can create an IL generator from our dynamic method. Get the IL generator, which now lets us emit IL. We can go and push in IL and create this dynamic method on the fly, right? So that's what the emit keyword is. And now we have a bunch of opcodes. And if you remember what it looked like, let's go take a look 1 second at the IL disassembly of our create native, right? These are our two opcodes. We have a new object of a constructor, right? And then we have a return. Two opcodes, guys. That's all we gotta emit. That's pretty easy. We could do that. We could do new object opcode, and the parameter the argument that goes to that new opcode is our default constructor, right? Is our default constructor, and then IL emit. That's gonna it's gonna call new object of that default constructor. That's gonna go on the stack. All we have to do now is opcodes dot return. IL done, guys. We just emitted 2 lines of IL. Very, very simple, right? We now need to go bundle this into a delegate. While we have a dynamic method, we can't call it yet. We have to go create a delegate from it so that it can get JITted, and then we can go execute it like any normal delegate or any normal function, right? So dynamic method has a way to do this very, very simply. Very simple, called create delegate. Ooh. And for this, we pass in our type of funct, right? So we want to create this delegate around, this is our signature, right? And it's just a function that returns our type. It's just a function that returns our type. And then we can use as, and then because it normally returns an object or returns just a basic delegate, we want to then cast it to what we're looking for. And object creator equals, let me see what I did wrong here real quick. Type of, that's not right. There we go, right? So we're going to go create a delegate, and a delegate just returns a delegate, but we also give it the type so it knows what kind of delegate to create. Then we can cast it. We just use as, right? This is just a cast operator into a function of t. And now we have this object creator. And then after this, we spent all that time just initializing our object creator if it's null. So now it's not going to be null. And since this is static, it's only going to be null, not null one time. We can easily, simply execute this. And this will execute our IL every time this happens, right? Let's compile this and see what happens. Things look like it compiled, guys. I'm going to enable chat. And let's see what's going on in chat. Let's talk about this. And we're going to go execute this, and we're going to go see what the performance looks like. All right, guys. Anybody not following what I'm doing so far? Diego, is this usable in normal application? Absolutely. This has nothing to do with game techniques, buddy. This has nothing to do with game techniques. This is just around object initialization. If you have any software where you are creating a lot of objects, for a majority of your time, this will help you. So the IL here, I want to go back to why we created this as a static class for a generic type, guys. The cool thing about .NET and C#, when you create a static class for a dynamic type, for a generic type, every type that you use in your software, wherever you use this static class of a type for the generic, you will get a new, unique, static version of a fast object allocator for this type. So since every type will have its own instance, one instance, right? That means every object will have its own one instance of an M object creator for this type, which means we'll have one object creator delegate baked behind this dynamic IL for every type of T that you use in your code. So funct T is making a function of type T. Funct T, guys, if you don't know funct T, this is just a wraparound delegates, right? This is the same way if you're going to write out an event that says return type T here's my delegate name, takes 0 arguments, right? So hopefully people are understanding what I'm doing here. The question is it going to pay off? Memory alignment possible in C#? Yes, we're going to talk about that in a little bit, buddy. How is IL? It's right here, my friend. So from the dynamic method, right, we create a new dynamic method from a return type with parameters. This gives us a new method template. There's no IL in here. We get the IL generator off that dynamic method, and from there we can emit IL into it. Hopefully that's clear. Okay, guys, let's go run this. I'm curious. I'm so curious what this is going to do, right? So let's go add on to our little tester here. So this is, we'll call this create IL. This is our IL creation method, right? So instead of calling create reflect, we don't need the type anymore. We're going to use our new function, fast object allocator of t, which is object dot new. That's all we want to call, right? So of a fast object allocator for this type. So when I give it a type, C# at the runtime is going to go give me a new unique static instance of this class in memory. It's going to be rooted in memory. And then if I gave this a different type, you know, if we say this of string, this is a bad example using string here, but and it won't even work. This will be a separate fast object allocator instance, static, right? So that means our IL, or our delegate, our function delegate, will be unique for the type. Here we go, guys. Let's run this. Let's see if it is any better. Let's go find out. Holy smokes, everybody. Holy cow. What did we have? Half a millisecond for our native. Our generic, our slowest, you think it wouldn't even be the slowest, you think it would be near as fast, is 10 milliseconds. We were able to shave that down to 7.6 milliseconds, right, by using the reflective way. Our IL generator has slammed that down to just having a 1 millisecond overhead, right? So by allowing us to continue to use generics or to continue to dynamically pass in the type, we can instantiate new objects with just a 1 millisecond overhead. Let's see if maybe we can get this even a little faster, right? I don't think we're really going to get this faster, but I want to go try. I don't know, Pyro. Let's go take a look, guys. We got this super duper fast, but maybe we can go even faster, right? So we're going to call a public static fast object allocator. And we're just going to bake all of this in up here. Not allowed. Okay, that's right. There we go. Now we've moved this into our static constructor. This only gets called once, and it's guaranteed to be called before new will get called, right? Guaranteed that our constructor will be called before new gets called. So now we don't have to do any type of branch testing. This is guaranteed to be there. We're going to be able to call this. Let's see what happens. Let's see if it works, or if I maybe broke. Uh-oh. Let's open this back up. Let's see what we get, guys. Let's see what we get. So, as I thought, as I figured, we're not really saving anything in there, right? Because if you think about it, a branch test and a jump in the IL, very optimized. It's not that's not a 1 millisecond type of operation. If it was, C# code would never run on a computer, right? So we're not really saving anything in our software by doing that. But it does make it cleaner. It does make it cleaner. There's no reason not to do it. So we should do it, even though it's not really giving us any type of performance boost. But the great thing is, we still only have about a 1 millisecond overhead. Let's take a look at the IL for this, because always go back to the IL, guys, right? Let's always go back to the IL. Let's take a look. Here's our fast object allocator. Here is our function, which takes a generic, right? What is going on in here? And this is why it's a little slower. I'm going to talk about why it's slower here in a second. We are, instead of just doing two ops, instead of doing two operations, where it's just a new object, and then a return. Instead, we're loading a field, right? We have to load our field into the stack so that we can then call a virtual function, and that's how funcs work, right? It's just going to call a invoke on it, on our delegate. So already, that's two calls, that's two operations, and if we remember what's the IL behind this virtual call, behind this funct, is another two calls, right? Because it's the new object and a return, and then we have the return here. So we're talking about 5 ops, 5 IL ops versus 2. And not just 5 IL ops, a call vert is more expensive than a normal call. We'll talk about that. So 5 IL operations, with one of these being a virtual call, versus 2 IL operations of no calls, right? Just new object is a built-in optimized op, right? So that's why we see half a millisecond versus 1.5 milliseconds, right? Makes sense. If 2 ops are half a millisecond, 2, 1, right, almost get back to 1.5, and that virtual bumps it up to round it out. And this will hold true no matter how many reputations we go. If we go a million reps, everything still holds basically true, right? Obviously, the more reps we do, the more likely garbage collection is going to be kicking in on us and starting to poison our results. Because since we are newing objects, we are allocating new objects, and then we're dereferencing those, garbage collection is going to be kicking in on us and starting to be a problem as we scale this up. But there we go, guys. Here is one way you can write a factory object allocator that's near as fast as native. And I know, I'm sure people have already written object allocators out there for and thought they were just as fast because generics, and hey, it's generic, everything is great. Unfortunately, guys, the easy way is the slowest way. The easy way is the slowest way, guys, right? Any questions? Any questions on what we just did here before we move on to another topic? I'll give you guys a minute. See what's going on. Would the fast allocator still throw type initialization such the type constructor fails? Pigeon, yep, of course. Kurgoth, for this object allocator, I will be posting it to the GitHub by the end of the stream, yes. Sure, Pyro. Massey, I don't know. The easy way would be doing new object, right? Then absolutely, right? The Motley Brit, absolutely not, guys. We're not, remember, the code we wrote is, there's really nothing magical going on. We're not bypassing the framework. We're not bypassing garbage collection. It's just a new object of that type in memory. Garbage collection is fine. Will we have fragmentation? Well, if you have fragmentation whenever you create a lot of objects and delete a lot of objects frequently, right? That's just standard fragmentation that's going to happen, no matter what method you use. On Net 5 framework, oh, Pyro. Now, To take this further, guys, you could keep going with my sample here, right? Now you know how to emit IL. There's other things you can do. There's other generators that we can optimize. For instance, let's take a look. We're probably not going to write it here. I just want to give you guys a sample, right? Properties. Properties are a good thing. Properties are a good thing, right? So we'll say object test property has a getter, and it has a setter. And normally you don't have to implement a getter set. It'll give you a backing variable itself, right? So I could just instead... Thank you guys for the follows out there. I might turn that off. I do appreciate all the follows. I do appreciate it, but I'm going on and off with it, and sometimes it has to catch up, and it might spam the stream, and we don't want that. So say we have a getter and setter, right? I want to compile this, and I want you to look at the IL. I don't know if you guys have ever looked at the IL of what happens behind a getter and setter. Ultimately, and I'm sure some people out there know exactly what this is going to look like, and that's great if you do. If you don't, let's go take a small little peek. Let's go take a small little peek, guys. What the heck is going on now? Well, here is the backing field, right? So for a long time now in .NET, if you create a property and you don't define a get and a set, it will create a backing field for you, and that's all this is, right? It's a private field of object. Here's our backing field for test property. You don't have to worry about that. Just know that there is a real variable of object for test property behind this, right? More importantly, this property got created with two functions. There's a get test property and a set test property, right? If it's responsive, you good, Diego? Oh, Diego. So here is our getter and our setter, and it's a very simple getter and setter because this is the default getter and setter. It's going to load up our arguments. It's going to set our field to the backing field, and it's just going to return it. And why do we have to load arg0 and arg1? Because we have to load our instance. This is an object instance, so arg0 is the this pointer. Arg1 is the backing field, and then we can return that field, right? And the same thing here. Here we just want to load arg0, the this pointer, and then we want to load the field to return it, right? This is the get. I'm sorry, this is the set. Load arg0 is the value. Load arg1 is the field. We want to set field, all that fun stuff. Getter, setter, very simple, very simple. You can go and write your, but again, this is a function call. Things can happen. There's lots of instances where these can be slowed down. If you want to optimize this, you could go do your own IL generator around your own properties and replace the getters and setters to do whatever you want, right? You can optimize around that. That's my only point. We're not going to go do it right now. I just wanted to point out that emitting IL is not just for this one-trick pony here. IL generation has many, many uses. It's amazing stuff. Something you can do around IL, and this might not be for performance reason. This might be for code extensibility. You can take a method, right? We could take a method. We could wrap a dynamic method around that method call and do some prologue and epilogue type of work around that method call with some custom IL, right? So maybe you have a function call, and maybe it returns a value, and maybe you want to turn that function into a coroutine-able function with an IEnumerable, right? Without having to have the function return an IEnumerable of your return type. Well, you could emit IL that wraps that function call into its own IEnumerable of that type and handle that in IL generation, right? It's going to add a small performance hit because it's now an extra function call, but sometimes the performance hit's okay to give us that extensibility. That's just some weird things you can do with IL going on. Oh, apps and Pyro, 100% correct, guys, right? Only optimize if you need to. What I'm teaching you guys here is not something you should go and implement for everything you're doing. If you find that object initialization is a potential bottleneck in your software, and you find that by measuring the performance, now you have a trick up your sleeve Now you have a trick up your sleeve on how to fix it. Have I done any videos on IOC? I have not done any inversion of control videos. But there we go, guys. Let's jump into another topic, yeah? How about we jump into topic number 2? What do I want to do for topic number 2? So now we've gone over fast object allocation. I think it's a very cool thing. I've been using it myself for a very long time, but I have special use cases where I need to be able to do that, and that professionally for work, right? We have some special use cases where we need to allocate objects very quickly for different reasons. So yeah, that's one thing. Let's talk about another optimization technique, guys. Let's talk about another optimization technique, and this is not specific to C#. I will show you how to implement a C# version for this, but this is a general computer science optimization. And anyone out there who's taking computer science courses or has a degree in computer science, maybe you've had a class that talked about this, or you've used this, and that's great. So I'm going to nuke all this code, guys. Don't worry. Don't worry, I'm just going to nuke it all. Most of it. I want to keep our measure, though. I want to keep our measure. I will put up on my GitHub, I will give you guys a project on my GitHub by the end of the stream that has that fast object allocator code. Any of the other utilities and extensions that we write today, we'll have up there. Don't worry about that. Just because I deleted it here, I still got it. Don't worry. We still have a fast object allocator right there, right? Memoization, guys. Anybody out there? Does anyone out there know what memoization is? If it is, I would love to hear Stream tell me what memoization is. Let's hear it, guys. What is IOC, Massey? Inversion of control. Another term is, I'm failing my words right now. Inversion of control, or DI, and all of a sudden I can't remember what the D stands for because it's 9 a.m. in the morning. Dependency injection, sorry. Woo! Inversion of control or dependency injection. They're almost interchangeable terms most of the time. And how we do in C# and .NET, how IOC is mostly done is via interfaces. And more reports to be coming to mind. Nice, nice. Expensive function calls and returning the cache result, right? There we go, guys. I love it. I love it. Everybody's got the answer here. Let's do it. Now, Diego, are you saying my class new object equals my class, but your faster has better syntax? So, Diego, as we said, if you remember back when we wrote our code, my code, it's always better if you know at compile time, if you know the class type, use that in your object initialization. Just use that class type. If you know it at compile time, if you're writing the code for it, use that. If you don't know it, if it's coming from a generic, it's coming from a template, or if it's coming from reverse type or a lookup type or something like that, you can use my code. Why is it called .NET and .com? Whoa, Frog. Whoa. All right, guys, let's take a look at memoization, right? We're going to we'll create a little example, and then we'll see how we can easily memoize it, right? Man, I always fail at pronouncing that word. So I'm going to go back to my full screen just so we can focus here. Just so we can focus, guys, right? Memoization. Let's create, I have one already. I wrote one yesterday, just so we have something to test with. I'm going to pop it up here. Find prime number, right? I just want a function that takes an input, returns a unique output tied to that input, and the function call itself is expensive, right? So this technique should only be used in a couple of cases, right? Case number 1, it takes input data. If you don't take input data, this has no use for you. It takes input data and does something with that input data. Hopefully it returns some output data, but it doesn't actually have to return output data for you to use this. It's more about the input data tied to the function execution. So that's use case 1, input data. Number 2, restriction. The function call cannot use any outside data for control flow or for computation, right? The function has to 100% only use your input data. Input data doesn't have to be just one variable. This can be as many variables as you want. Our case is just one. But as long as the function is only executing against that input data, you can use this technique. If it's executing against outside data, you cannot use this because you will get back invalid results, cached results, right? But that's okay. Even with those restrictions, there are a ton of use cases where this can help your software. Like finding a prime number as an example, right? Obviously, you can use your own lookup table and says, hey, I've already done this prime number lookup. Don't recall that function. But there's a lot of overhead. You got to go write this every time. You got to create all these crazy lookup tables. We can wrap this ourselves in .NET and make this easy, right? So while this is not as esoteric as what I just did with the IL, this is still a very valid case, and you'll probably use this more than you use my fast object allocator, just because, right? But we have a find prime number. Let's go write a measurement of this and just see how long it normally takes for some test data, right? So let's see, int reps, go back to 5, int it's 50,000, right? I don't know. Let's give it a nice large number to really measure some performance, right? And then we want to measure. We'll call this our baseline. Reps, right? This is an anonymous function again. And in our anonymous function, iterate through some reps. No, I'm sorry, not reps. What I'm talking about, iterate through our iterations. I had to fix myself there for a second. And what are we going to do in here? We're just going to go find prime number. And I'm just going to give it some number, right? Let's go find prime for 45. That's fine. Just want to throw something in there. Let's let it run. All right, let's see how long this takes. Let's see what our baseline takes. And we are in release mode. Always important to make sure when you're measuring performance. How long is this going to take? Will this take too long? No, not too long. On average, 376 milliseconds, right? And let's run that again. Make sure we're staying consistent. 376, 74 milliseconds. Excellent, excellent stuff. All right, how can we go memoize this? How can we say, okay, well, this is taking 45. We're always going to get back the same output data. We don't need to call this every time. How can we go fix this? How can we go make this better? Let's go add a new class to wrap this. Let's see if I can spell correctly. Let's call it memoization. And this will be a, that's fine, public static class, something what I want to call this, utils. Because this is going to be a static method. You can even make this an extension method off of something if you want. All types of crazy stuff if you want. But really, this is a very simple implementation I'm going to do right here. Public static func that takes in an argument. That takes an arg. Has a return value. So this is, we're going to memoize functions that can use one argument. If you want to expand this out to multiples, you can do that, right? But for our use case here on stream, one argument with a return type, right? Of arg. Oops, sorry. Of arg and ret, right? Oh, you know, I'm thinking if I want to make this an extension method. I am going to make this an extension method. Yeah, let's just do that. So this is, if you've never done an extension method before, guys, this is how we're going to do an extension method. So we are going to extend any func of this template type. Yes, you can do extension methods off specific types, right? So any func that takes one argument and one return value, we will have a memoize function around it, right? I'm going to call this our functor. So there's our function. We got to go build this now. How a memoization works, right? We need some type of ledger. We need some type of lookup table for input to output data. So we can go create that. And why am I putting this in our extension? Isn't this going to get called every time? Well, it's not, and I'll show you why. So we're just going to use some basic .NET types, right? You can optimize this however you want when you get around to it. So we're going to take in a dictionary, again, of arg and ret, right? So we want to look up an argument, value, and to its return value. Very simple, right? We just want to create a new dictionary. But you'd think every time this gets called, we're going to get a new dictionary. Well, yes, every time this gets called, we get a new dictionary. But this is not our function, because, see, this returns a function, right? We're going to memoize a function. We're going to return a new function. I'm going to create a new dictionary for that. What are we going to return, then? Return, and I'm going to create this as a lambda, just because we're cool like that. I'm going to return... we're going to call it arg0, right? So this is our... I'll make it a little easier for you guys, because I was about to type this in an optimized fashion, and I shouldn't do that. So what are we doing? We have a return value, right? Here's our func return value. And then how all memoization basically works, we just check our lookup table, try get value. And why are we using a try get value? Why aren't we saying that contains and then lookup, right? Try get value is if you don't know, around dictionaries, right? This is not very advanced, but always use try get values if you can, guys. If you use a dictionary and you want to say, hey, if this contains, return our value, otherwise do something else. Try get value will do that contains for you and give you back the value at the same time and return a bool, true or false, if it contained it or not, right? So arg0 is our input parameter, right? Because this is a lambda. We're creating a lambda around arg0, which is going to get passed in. You'll see what I mean when this is done. And if this returns an out of func return value, right? So if this did not contain it, if this was not in our dictionary, that means we've never run this function against this argument value. We want to just go do the slow function call of arg0, right? So here is our memoization function. We're going to wrap this function, functor. Here we need to go call it with this argument that's going to get passed in, get back our value, and a memotable.add of arg0 of func return value, right? Just go create a lookup of this. Go store it in our memoization table. And that's really all I have to do there, because down here we're just going to return the func return value. So this, if it's not there, go add it. Go store it in a local variable, right? But go add it. If it is there, this will never get called. We don't have to recall the function if we already have this input value cached. And then we want to go and return our func return value, right? And there we go, right? So now this is a lambda. So what are we building here? What are we building? We're building a lambda anonymous function. That's what this is. Then we're going to return it because this anonymous function can map to a funct of arg return, right? Because this has the this has our return value of ret, right? Ret return value. So the lambda knows what's up. It has an argument which we pass in as arg0. So we're going to get back a funct of arg0. That's what we're going to return from our memoization. Our dictionary here, since we created outside of the lambda of the anonymous function, this is created just once. The instance of this is now tied into this anonymous function. So as long as this anonymous function exists, this table will exist, and they'll get cleaned up together, right? So we don't have to do any type of weird storage of this dictionary. It's going to get tied to this funct object, right? Great thing about anonymous functions, it'll allow you to tie data together that you don't have to go build yourself. So there we go, guys. We have ourselves a memoization function. Let me go fix what I have. Oh, public static, right? If we're using an extension method, make sure it's a static. So remember, we're extending funct of this, right? Right. Well, then, we have it. How about we try and go measure it now? Baseline memo. So what we want to do before we measure, how how you memoize a function with how we did this, we need to do that, right? So we want to do a var memfunc is based on our find prime numbers. Let me see if I did this right. Am I thinking about this right? Based around our funct of this, right? A funct of arguments, int long. Should have, let me see if I have this in here. If we did this the right way, because well, we can always call it like this as well, right? Utils memoize of our int in long. We pass in find prime number. I'm not sure why it's not passing it on here, because normally we should be able to do memfunc find prime number of memoize. I'm thinking of that wrong, but that's okay. This will work as well. We'll have our memfunc. So this is going to memoize our find prime number function, right? And instead of calling find prime number, we just call our delegate, our funct, for our memoization, right? So now if we run this, and we'll let this execute, without any surprise, by the way, we get a huge performance boost because we're only passing in one static number, right? We're passing in one static number. Let's close that down. So our baseline is, our average is going to be the same time it takes to run it every time, whereas in our memo, this is, since we're only passing it in one time, we only have to execute our function one time, and this is going to do a dictionary lookup, which is very fast. So every time we run this function after the first time, which by the way is our warm-up method. If you notice if you remember in our measure, we don't time our warm-up action. This warm-up action is warming up that dictionary as well and storing it in there one time, right? We're going to get it stored in there one time, and that's why we don't have a max of 300. Because it's already been warmed up, so every time we call it now, it's the memoized version. It already has that cached in there. We could solve this, of course, in our measure by passing in some random data, which would show us that our average would go up, of course, every time we call it the first time with new data. It's going to have to execute our function, and it'll get cached. So here's one way you can memoize stuff. Right now, some words of caution around our memoization. This is not thread safe. Remember, we're using a dictionary, and this is not thread safe at all. We can make this thread safe by using a concurrent dictionary. If I can type correctly. I'll get chat in a second, by the way. So if we use a concurrent dictionary, we need to do a triad. Yep, and now we've just made this thread safe for the most part by making a concurrent dictionary. This is going to slow our performance down ever so slightly, but not really a noticeable measurement, right? Not really a noticeable measurement when we make this a concurrent dictionary. But now that it's a concurrent dictionary, it's thread safe. You can have multiple threads calling into this delegate or this static func. The dictionary will be thread safe around, and that's the part that was not thread safe. Let me go pull up my screen here and see what's going on in chat. See if anything interesting is being said. So, any questions on this, guys, that I can answer about memoization? This is not a specific C# optimization. This is a general computer science optimization that we use a lot of times. You got to be careful we use it though, guys, right? Only memoized functions. We already talked about restrictions, right? One, need to be a member variable. Oh, why does it need to be a member variable? This is not. Remember, guys, we're creating a static function. All we're returning here is a lambda. We're returning an anonymous function here, right? So since we're returning an anonymous function, we're creating a dictionary outside the function. But since we're using the dictionary inside the anonymous function, .net C#, when it compiles this, is going to move this reference table into here, right? It's not going to create it out here. It's just going to say, hey, I have a reference to this. And because of how .NET works and how garbage collection works, since memtable has a reference in this function, garbage collection will not delete this. Would this speed up lookups to a huge dictionary? Yes, Jim. Well, no, Jim, no, Jim, it would not. If the lookups in the dictionary is same as a normal dictionary, you would get the same speed, right? Because this is all this is, Jim, right? This is just a lookup into a potentially huge dictionary. You want me to do a step-by-step debug? Absolutely. Let's go to debug mode. Let's step through this in the debugger. I like that idea. We'll put a breakpoint up here, and we'll put a breakpoint inside the function call, right? And then on top of that, we will do a breakpoint right here. When we're going to call this, right? This is the dark theme. Why not create the object inside the lambda? Zoofy, I will tell you exactly why we don't want to create the object inside the lambda when I step through this. This is the dark theme with some custom color modifications. Yes. So let's run this, guys. Let's run this in debug mode. And let's see what's going on. So, we have not hit our lambda yet, right? We're calling our memoization. If you look at our call stack, we're at our main, right? This is here. This is when we're creating the memoize function. You don't want to call this every time. You want to call this once to create the memoize version of your expensive function, and then you want to use this instead of the expensive function, right? So the first time we call this, we are going to create our memo table. So now we have a new dictionary. Excellent. And we're not going to call this function, right? This is just going to create the lambda. This is going to create the anonymous function. It's not going to execute it. This is not going to get executed. It's just going to get created. No problemo. We love that. And so nothing's happening. All we've done so far is create a dictionary, and we create an anonymous method. That's all that we've done so far, right? Now when we jump into here, when we want to go execute our lambda, this is the lambda we created. This is what got returned from the memoize. It's that lambda. If we step into the lambda, we're now inside the lambda, and this is why we don't want to create this dictionary inside the lambda, because if we did that, every time we called this function, we would end up recreating this dictionary, very expensive, and also we would lose our table, right? We create it once outside the lambda, and now we're just referencing it here, right? We know what memo table is, because the lambda builds it in as a local variable, as a reference, and it won't delete it because of that. Garbage collection won't delete it because there's a reference to it. Islinator, no reason. I'm just typing code quickly. No reason. You should probably give this a capital U. Yep, absolutely. So if we execute through this, right, we're going to step through this. We're going to look at our memo table. We're going to see that there's nothing in the memo table, right? So when this try get calls, it's going to fail because there's no return. There's no lookup to arg0 of 45, right, in our memo table. So we're going to have to go and execute our find prime number, our functor that got passed in. Let's step into that. And you can see it's just calling our find prime number. We're not going to run that because that's going to take a while. And then the return value, that's 197, right? That's our return value based on argument 45. And we want to go add that into our memo table now. So now we have a lookup. Now we have a lookup of 45 to 197, right? And then we're just going to return that. So there we go. Next time we execute this function, we step back in. We still have our memo table, right? Because it was created outside the lambda. We're just referencing it. It's created once. Now we're just using it. And now it has this lookup of arg45. And we're not going to step into here because our get value returns true. And we have the function value, right? That's all we're doing, guys. Very, very, very simple memoization, but it's just an easy way for us to wrap it. Very simple way for us to wrap it. Let's take this off. Step on out. Step on out, right? We're using a lot of lambdas in our code here. Anyone? Any other questions on memoization? On our implementation of this memoization? I'm hoping somebody asked the right question here. Otherwise, I will just have to spit it out myself. I'll give you guys a moment. I know there's a huge delay. I've had my music playing this whole time, haven't I? Oh well. That's life, I guess. There's like a copy the first result and store it in the table, and the next you just do. Yep, that's all we're doing, Diego. Right? As long as the input value is in our lookup table, we just return the output value from the lookup table. Is there easy? There we go. Pigeon King asking some good questions, right? Limits, guys. This is a dictionary. What happens if we call this memoize function 500,000 times with 500,000 different input and output types, right? Ultimately, this concurrent dictionary is going to have 500,000 lookups in it. While the performance of that is going to be fine, it'll be fast, it might become a memory constraint, right? Try wrap the function name. Oh, I see, Ragathan. You're probably right. Yep. So, I'm not going to do it here. I just want to put this out as a thought experiment for you guys. How can we do that, right? How can we do constraints around this dictionary that's ever growing? Well, it's not that hard, right? You can use it. There's all types of container formats out there that can give you a max, that can give you a cache, right? There are caching container formats out there that you can say, here's a cache, here is time to live, age, how often are we accessing this, expunge lookups that haven't been used more often, right? There's all types of patterns we can use to make sure this dictionary stays at some limited size, right? We're just using a basic dictionary or basic thread-safe dictionary here. There's other container formats out there that you could use that will reduce performance a tiny bit, but for a good reason. It'll still be faster than calling your function initially, right? But ultimately, you'd probably want to come up with some type of caching container that can do that for you very easily. The other thing about this, guys, don't memoize functions unless it's a very, very, very slow function, right? Don't memoize something that's already quick to run. You're not going to gain any performance out of it. But if you find that here's a function that has a high cost, not just high cost, by the way, here's a function that has a high cost. It's called a lot, and oftentimes we're calling it with the same parameter, right? You can memoize around that, and you'll get some nice performance boosts. And that's it. And if you want to extend this out to more arguments, a func can take all types of in types, right? You just have to modify this however you want. Let me see if there was a quick fix for this. Var memfunc equals find prime number dot. I don't know why I can't. I don't know why I can't think of that right now, but that's fine. We got it working. That's what's important for showing you guys on stream. All right. Any last question before we move on about memoization? I know this was not a specific C# thing, but I find that I use this. I use this sometimes in C# code, only because some things in C# can be a little slower than in native. And you can also use this in C++. You can use this in Python. You can use this in Java, right? This is a generic, computer science technique we use. It's not specific to .NET, but I don't see a lot of people out there that use this when I think they could be using it. I was suggesting instant sort memories are all in order sequences, mapping them to sorted ones. Thoughts? Not. That could work, Massey. That could work. Wise in code? Yes, right. JPEG MP3 compression? Yes. And as always, Doxbury, guys, everything we talk, most of what we're going to talk about today, write first, measure second, refactor for performance third, right? Don't just go memoize something because you think it's going to be slow and think it's going to be a problem. Profile your code, know it's a problem, then go implement stuff like this. Am I creating a new stopwatch in our measure? Yes. And yet, yes, you do not have to create a new stopwatch in the measure, guys. I understand that. You could reset your stopwatch. It's all right, guys. It's just a simple little measure function. What is faster using it? It depends on your use case, HS. All right, guys. Let's move on. Next business. I'm going to, as we always have been doing, I'm just going to nuke all this test code. We talked about it to death. Let's move on, yeah? Let's find something more fun to look at. Okay, what have we talked about so far? Fast object allocation, memoization. Let's go into... This is a quick one, guys. This is just a little technique. This is not necessarily... This can be used as a performance thing. I think a lot of C# developers don't know you can do this. There are restrictions on it, like everything, and we'll talk about those. C#, if you're a C++ or a C developer, guys, unions, right? How much do you guys love unions out there? And wish you could use unions in C#? Let's talk about unions, guys. I want to talk about them. Unions, right? Unions. And if you don't know what a union is, go Google it. I'm not gonna describe a union, but I'm gonna show you how you can implement a union in C# or in .NET very, very easily. This has some restrictions, and once I implement it, I will show you guys. If you don't know, if you already don't know, we can create a struct. We'll call it a byte array. Right, and this struct is going to have a public byte, byte 1. Let's create 4 bytes. 2, 3, and 4. Very simple, right? 4 byte. Here's an array. That's awesome. And what is also 4 bytes, guys? What is also 4 bytes in C#? Well, an int is 4 bytes, right? So wouldn't it be great if we can map these bytes to this integer without having to do any special magic software, any special code? Let me go back to full screen here for you guys. Sorry. You think they're nonsense, Massey? Okay. Best byte array 2015 coming online, guys. So here's a quick byte array which just maps 4 bytes, right? But also 4 bytes is an integer. Wouldn't it be great if, for whatever reason, I don't know what your reasons would be, I'm just giving you guys the power. You decide how you want to use it. Wouldn't it be great, though, if we can map these bytes onto the same memory address of this integer, right? That's basically a union. Well, we actually can do that in C#. We can actually do that. We want to put an attribute on here. If you don't know what attributes are, please go look up attributes, guys. Attributes are kind of amazing. You should implement your own attributes for all kinds of stuff. I don't see enough attribute usage used in C#, but I would like that. What we're telling this is, here's a struct. I want to tell the compiler and the runtime, I want to explicitly lay out the structure of my struct. And it will say, okay, go for it. So that's on a struct. You can put a struct layout. We can then use field offsets for every field within our struct, right? Now, field offset is the byte offsets. The byte offset from the start of the struct array, right? So, well, since these are bytes, we just want byte offset of 0, 1, 2, 3, and 4. And how we bind this into a union is we can also set the int to have a field offset of something that's already been used, right? These are not have to be unique. I can have byte 1 and byte 2 share the same offset so that anytime I modify byte 1, byte 2 would also get modified for whatever reason. I don't know why you'd want to do that. But here we go, right? We have 4 bytes, which is the size of an integer. We explicitly laying out the offsets. And then we can say this integer should also map into the first address space, the first offset of the struct. and these will lay out on top of each other. And that's how we can do unions in C#. So let's go test this real quick, right? So I have a byte array. BA. I want to say BA dot byte 1 is equal to 0. Let's use the hex codes here, right? It'll be easier to see in memory, or however we want to spit this out. You know what? Let's not. I'll make this easier for you guys. We'll say 128 0. We use half a byte, right? 0 0 0, right? We're not setting our integer. We're not setting our integer. Let's then just console write line. This is a very simple one, guys. We'll move on to something else here in a second. Byte 1, 2, 3, and 4. Byte 1, 2, oops, 0, 1, 3, and 4, and then also we'll get int 1 in here, right? I1 is equal to 4 here, okay? And then we can say a ba.byte. I see my bug. I already see my bug. I'll go fix it in a second. Let me just lay this out. We just want to see what data is going to be in here, right? And ba.int. Change this to 1, 3, and 4. All right, so if we run this, if we fix this, what doesn't it like? You sub on if okay. Oh, that's fine. Because it's a struct. So we'll initialize it to 0, and we'll see if this gets overridden, right? Let's put a breakpoint here, and let's just see what kind of data we're getting. So, our integer now is 128, right? So if we set byte 128, 0, 0, 0, our integer is getting changed. More to the point, if we initialize everything to 0, and more likely how you'd use this is manipulating our integer here, right? If we manipulate our integer, and let's do this as a hex, right? So we can see what's going on. 0, 0, 0, 0, 0, 0, FF. Let's set the first byte to what we want. And if we look at this now, we can see that the first byte is getting set based on our flags here. And yes, these are reversed. That's how it works, guys. That's how it works. This is byte 1. That's going to be byte 2, byte 3, and byte 4, right? For instance, if I want to set this, and you can use this for lookups. What did I mess up here? 1, 2. Okay, that's right. 2, 3. I can't type today, guys. Let me retype this. Alright, see what happens here, right? If we store this out, we can see that we're setting both byte 1 now, and I say it's B1 here, but this is B3, right? So that's what I want to talk, that's just what I want to show you guys real quick about unions within C#. There are some restrictions on this, guys. There's some restrictions on this. Let me go back to my chat here. Yes, I know, Zoof, I should use a uint, of course. It's just a sample, right? Yeah, what would be the use case in doing this, right? What would be, why would we want to do this? I think somebody had a good suggestion. We could turn this into, make that a uint, right? We could turn this into a color int. And now we could specify color as 255, RGB, right? 255, 128, 0, 255 full alpha. You probably want to get a default initializer on this so you don't have to initialize everything at once. Color int, right? So now by setting some color values explicitly, very easily, it will instantly map into a color uint if you want to store that as a uint somewhere. So C# doesn't actually define. So that's Indius, right? That's little Indian, big endian, guys. That's where this can fall apart. This is where this can fall apart. Since we're explicitly putting some offsets in here, this code will not be this will not be usable on other architectures that swap this around, right? While this will work on Windows, this might not work on a Mac, might not work on some Unix systems, right? So you got to be very careful. You got to be very careful. While this will work in some of your cases, you just have to be careful where you're trying to target your software. If you want your software to run on other hardware where this is going to get switched around, right? When we say this is going to get switched around, you would have to put this at 3, right? You would have to say field offset for this to be 3. Well, even that won't work, but you know what I mean. You have to switch our bytes around. Unflexible code. But it's not. Yeah. Indianness is very painful in C#, guys. However, 90% of the time, this is probably not going to be an issue for you when you're writing .NET code. But just keep that in mind. If that is an issue, maybe you don't want to use this. If it's not an issue, this is a very handy little trick for you guys out there. Themobrit, yeah, you don't want to just take your struct and send it over the network. You always need to correct that data, right, on both ends of the pipe. So, another use, by the way, I don't know if anyone does this. If you're trying to use C# code and you're trying to communicate with native code, if you're trying to interrupt with native code, either pinvoke or execute within your process, you can execute native functions, by the way. There's ways to do that. If you're doing that type of stuff, sometimes the struct layout has to be explicit because you're trying to take a C# memory address, a C# struct, and you're trying to push it into the native boundary, and the layout has to be the same, right? So sometimes you got to do this for that as well. Register, C# has a communication layer to native code, yes. So that's what struct layouts are, guys. You can use this for unions. It's not just used for unions. Sometimes, like I just said, you have to have an explicit structure layout if you're communicating between .NET and native code, right? If you're trying to pass data, if you're p-invoking, sometimes you have to have a struct layout. And that's all that's doing. Okay, guys, let's move on to another topic. I just wanted to show that very, very quickly. I think it's kind of a cool little feature. Not used all over the place, though, right? It has some very specific uses. Like everything we're talking about today, guys, some of it has very specific uses, and that's okay. That's all right. What do we want to talk about next? Let's talk about some unsafe code, guys. Let's talk about a little bit of unsafe code and what that means. What does unsafe code mean in C#? Is it really unsafe? Is it not unsafe? I don't know. Let's go find out. Let's go find out. Let me go back to full screen. And let's go write some code to make some stuff happen here, guys. Get rid of our test software. So what does it mean, unsafe code, right? Unsafe code in C#, and we're going to go enable it right now. Unsafe code. First, you have to make sure you allow unsafe code in an assembly. Your whole software doesn't need to be unsafe. The assembly that's going to use unsafe code just needs to be flagged to allow unsafe. And even then, you don't explicitly get unsafe code. Sometimes you don't explicitly get unsafe code. You still have to tell the compiler explicitly where you want to use unsafe code. But why would you want to use unsafe code? There's for a couple of reasons. First of all, unsafe code gives you pointer access. It's still protected pointer access, though. Just because you're getting a pointer in C# does not mean that you can use that pointer to do buffer overruns or buffer underruns. That stuff is still protected within the sandbox of the .NET runtime, and that's fine. But it does give you some power behind that. Okay, guys, here we go. Unsafe. So if you want to use unsafe code, you just need to wrap your context. You can put unsafe at the function level here. This whole function will allow unsafe. If you don't want to do that, you can wrap a context around unsafe. So just a subset of your function allows unsafe. And once you're in an unsafe context, right? Once you're in an unsafe context, you can start using pointers. Oh my god, we got pointers. This thing supports pointers, guys. So let's assume that outside of our unsafe, let's create a byte array. Let's go and just create a byte array, right? Actually, let's create it just very simply 16 bytes, right? Small enough byte array. We could now wrap our unsafe usage around this. Within unsafe, oh, let's see, let me try and remember here. We get a p bytes. This is right. I need to wrap this. All of a sudden, my unsafe usage is following me right now. That's okay. I will look it up real quick because I'm always trying to remember. That's right. Sorry. We need to wrap this in a fix, right? So we need to pin this memory, and that's why we use fixed. I'm like, what do I need to fix here? And this becomes a using context in here, right? So now, cannot implicitly, it will go away. There we go. So why do we use fixed, by the way? Fixed tells the garbage collector that I want to fix this memory. I want to pin it. I want to pin it. Do not move this memory around. In the garbage collector, your objects, right, they're not pinned in memory. The garbage collector can actually move the addresses for all this stuff around for optimization purposes as it goes. However, if you want to use unsafe code for the context in your unsafe code, you have to make sure this memory gets pinned because now we're using pointers to memory addresses, and those can't be moving while we're trying to use it. Otherwise, we get corrupt data, right? So you need a pin. You need to fix this memory in the garbage collector so it doesn't move it around anymore, just for a brief amount of time so you can do stuff, right? So now that we have a byte array of p bytes, you can continue actually using p bytes just as an array, right? Equals 1. What did we create? 16? We'll just use a few of these, right? 1, 2, 3, right? We could use this as an array, but why would we want to do this? Why would we want to do this? Why would we not just want to say bytes of 0 equals 1? Why not? Why not, guys? Why not? Well, I will show you why not. I'm going to show you IL, guys. We're going to go back into IL. I'm going to say bytes of 0 equals 1. All right, we'll say 2, just to make it a little easier to find in the IL. Let's compile this. Let's go look at the IL, and hopefully it will tell us why we do stuff like this. Let's look at our main method, right? Okay, so this is going to be a lot of IL, right? We're doing a lot of crazy stuff here. What's going on? We create a new array of 16 bytes. That's great. We want to load store location. Great. Load location. Load a 0. Load a 0. Load 2. Set element. Load 0. Load 1. Oh, sorry. Load location 0. Right. Load a 1, load 2 on the stack, set element, repeat, 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 all the way through. Are we in debug mode? Why do I have no ops in here? Oh, let me fix this. Sorry, guys. Let's take a look at this properly. Let's look at this properly. Okay. No ops are gone. Still the same code, by the way. I just want to get rid of those no ops. Dupes, fine, all that's great stuff. Here is where we will load into IL. And the opcodes are going to look a little different, right? So we're using a store element to store the stack 2 into this element of the array, right? Based off this element, store an element. This is store an array element, right? Excellent stuff. How do we do this in the in the unsafe fashion, right? How do we do this in the unsafe fashion? Well, how we do in the unsafe fashion, if we do a STD, I forget what the opcode stands for. I always have to go look that up, but that's fine. We do a conversion, and then we just call an add. See how we're just calling an add on here, right? Because we're adding from 0 to 1, because p bytes, and you see there's a bunch of adds going on here, because p bytes is an array now. It's an address location, and that's why the conversions are happening here to integers. We're just adding 1, and I want to add 2. Then we want to store a 1 there. I want to add 3 to our base, right? We had 3 from where p bytes started, and I want to store it. So the IL looks different between the two, and why do we care about that? Well, store location has some safety checks going on, guys. Since this is safe code, what happens if I was to say bytes 25 equals 2? As you can see, the compiler has no idea that bytes 25 is wrong, right? Because the compiler should not know that. Maybe in this case it should know that, but generally the compiler does not know that bytes 25 is wrong. Okay, so let me close this down. Close that down. So the compiler does not know that bytes 25, right, element 25, obviously we're over our bounds, right? This is a bounds, out of bounds condition. The compiler doesn't know this. The runtime, though, because we're using that store element op call, in that store element op call, it's doing bounds checking every time we set the element of an array. So every time I want to say 2 of 0, 2 into 1, 2 into 2, 2 into 25, it's going to do a check on our array to say, hey, is 25 within the bounds of our array, right? Is it out of bounds, right? Is 25 greater than 16? If it is, it's going to throw an exception, right? And we'll see that right now. Let's run this real quick. Work. What do we get? We get an index out of range exception, right? That's the runtime doing that store element, doing a bounds check on our element here to see that that is not allowed, right? So that's great that it does bounds checking for us, but nothing is for free. We get nothing for free. Nothing's for free, guys, right? So because nothing's for free, that bounds checking has a cost. That bounds checking has a cost. And of course, the bounds checking cost when we're just doing it 5 times right here is nothing. But if we do this bounds checking a lot, and I don't know what your usage is out there, but there are a lot of cases where you're iterating through arrays, right? And this is not even just arrays. Anytime you have some type of array lookup, it's going to do some type of bounds check, especially on base arrays. It's going to have a bounds check on it, and that can be expensive. However, if we write it like this, since this is not a store element op call anymore, we're in unsafe, and that's what it means by unsafe, guys. Unsafe means it's not going to do some of those safety checks for you. It's not going to do that bounds check. So if we try and do p bytes of 25, let's go see what happens when we do this here. Let's get rid of here. Let's put a breakpoint in here. As you can see, no exception. However, it's unsafe. You just corrupted memory somewhere else in your application. You're probably still going to crash, mind you. Not good to do that. It's not good to do that in general. But there was no bounds checking that just happened in our array. There was just no bounds checking, right? Which is awesome, because what if we are iterating through arrays like this? Often, we can get a performance improvement by taking away that bounds check. By just using some unsafe and fixing that memory, iterating through it, unfixing it, and you're good to go, right? Right. Now, understand, guys, by the way, understand when you use a fixed array, if you want to get a pointer, you can only get a pointer to value types. If this was, say, an array of string, this was an array of string, this would not work. Let me comment all this out. Comment all this out. If we try to compile this would not work, right? Because you cannot take the address of, get the size of, or declare a pointer to a managed type, right? It's got to be a value type. Structs, you can do this on structs as long as no field of the struct is a reference type. But you can't do reference types, right? You can only do unsafe. You can only do pointers to value types, which is fine. There's still plenty of cases for that. The .NET just does not support unsafe pointers to reference types. It's just how it works. It's just the limitation. That's okay. If you need that, you gotta interrupt into native code, right? If you write C++ CLI, if you write C++ CLI, you could do it there. There's a marshal, though, that would have to happen across that data barrier, and it can be expensive. But, so here's a way. Think we should maybe go test this, yeah? Should we go test this? Let's go see what kind of performance hit bounce checking adds. I don't know, Ages. Let's go find out, my friend. Let's go find out. Okay, let's create a method, static void baseline array. In our baseline array, we just want to do this. We'll optimize this a little better. So we create a byte array of 1024. Let's get a sizable. Let's get a sizable array out here, right? For in I, let equal let bytes.length. Increment our I, and we'll just say bytes of I equals I. And we'll convert this down to a byte. Sure, that's fine. Do the cast. I don't care. Okay, so there's one method. Let's go run this. We can get rid of you. Let's go make our other method, actually. Let's go make both of these first. Then we'll run them. Unsafe array, right? And we'll wrap this whole thing of static unsafe void. So then we can just do our fixed buffer here. And then in here we'll do a for int I less than bytes dot length. P bytes, there's no length property on it, right? Remember, it's just a pointer. It doesn't know how long it is. But this is how we do. This is how we're going to validate that we're not writing past the length that we should. And there's a few ways we can optimize this usage too, by the way. But for now, this is fine. Let's just keep the code the same. I'm curious. I don't think we're going to see a huge performance boost. Maybe not this size, but we'll boost it up. We'll see what we get. Absolutely, Britt. Always, guys. Don't just blindly use these techniques. These are techniques you can use once you find a performance problem in an area around this, right? Then you go and use something like this. So let's run it. Let's run our measure. Baseline. 5 reps. Create a lambda. I should have kept some of this code around a bit. I've been retyping this a lot. Let's see. 100,000 times, right? And we just want to run baseline array. Just make sure we clean up memory. Wait for pending finalizers. Hopefully you guys know what finalizers are out there. I sure hope so. Okay, let's run this real quick. Let's see what we get. So we get an average time 147 milliseconds, right? Let's run that a couple times, make sure. Average time 147 milliseconds. Cool, cool, cool. Cool, cool, cool. Let's run our unsafe. Let's see, maybe this will even be slower. Who knows, right? Who knows? At some points, things are going to be slower, some things are going to be faster. We just have to go play with that number. But let's find out. So in this case, with this small of a number, and this is important that we check this stuff, unsafe is slightly slower, right? Let's boost up the size of our arrays. And I'm curious if I might refactor this, because garbage collection might be playing a role in here. Let's find out first. We're going to boost this up. It's going to take a little longer to run. And this is why we always measure this stuff, right? And we'll see if it's still longer. I'm going to take the initialization out. Let's do this. We could be getting some false positives. Let's just initialize our byte array out here, and we'll reuse it in our code. We'll just reset through it, right? Let's just make sure that this is not a major problem for us. And we'll tear this out as well. Even though the compiler will do this for us, let's just be explicit. We'll do it on the other side as well. Make sure it's the same code as close as possible. But the compiler will usually optimize this type away for you. Let's see what we got now. So now we can see unsafe is starting to edge out, right? So moving that byte array out of there, which we don't have a garbage collection happening. Garbage collection can really start poisoning your measurement results. You got to be very careful. We can see that unsafe is starting to eke out, but at this size, it's not that big of an eke. Let's see what happens as we increase our size. And like I said, guys, this is a very, very specific optimization you got to be careful about. But there's also other things we can do with this, which I will show you in a moment. I just want to show you the performance benefit of possibly using this. It doesn't look like there's a major performance benefit when we're using it in this way. Of course, you can rewrite this slightly, right? We can do p bytes plus I equals byte of I. Unless I'm freaking myself out here. Why is this not working? Give me a moment, I'm thinking about this. We could... You can say, I know, okay. Right, we can do this. We want to dereference this. There we go, and then sorry, I forget what I want to do. So instead of using an array accessor on it, we can increment, oh, right. We gotta cast it, sorry. Should be good. So when on the fixed variable, we can't modify the address of this, but if we get a reference to that, we can then play around with this in here, right? So let's see what this does, out of curiosity. Let's see what we got here. So here is now we can see where the performance benefit kicks in, right? If we write our unsafe code correctly, we will start to see that there is a performance benefit. And in fact, this is a pretty decent performance benefit. We've almost cut the time in half just by those bounds checks, right? Just by simple bounds checking. And I want to go look at the IL to see how the IL looks for this, because I'm curious. And the bigger the array, the bigger the savings going to be, right? So if we bump this up to an even larger array, we'll see a nice little performance boost, guys. And that's what I was trying to get to. But we have to make sure we write our unsafe code correctly. Bounds checking, guys, bounds checking has a cost. It's a good thing. 99.9% of the time, bounds checking is an excellent thing. But there are some cases where you don't need the bounds checking. You're very explicit. You know exactly what you're doing with your data. And you need optimization here, right? So you can take away that bounds check and not worry about it. And let's see, guys, this is a really long-running test, right? Really long-running test, which is good for stuff like this. We want to get a really good sample. And as we can see, still holding on to almost a 100% decrease in performance, right? We running at about half the time as our baseline. Very nice little optimization. Anyone have any questions on that real quick? And while you ask your questions, I'm going to also show you a few other things we can do with unsafe. I'm not done with unsafe yet, guys. We're just starting to scratch the surface here with unsafe code. I'll show chat again. Let's get the chat up. And I want to look at the IL. I want to look at the IL for this, because I'm curious what the difference is. If we look at our unsafe array, right? What's it doing in our code here? We still have the conversion. Interesting, it's interesting. Load to convert. It looks like the same code. There is just some optimizations around. Why are we doing a true check? 3A. Load lock. Back to 2D. Interesting. Oh, this is our for loop, right? This is, yeah, that's fine. That's our for loop. Well, okay. I would have to look at this in more detail, study this, to see exactly why this is running a little faster when I do it this way, but that's fine. Give us a different kind of indexer that ignores bounds checks, since that's about the only use for unsafe code at the moment. That's not the only use, Ragathan. That is not the only use, and I'm about to show you what the other use is for this, right? So here is, here's another way we can think about this, guys. We are, and this is, you can only do this with unsafe, or you could go use my union that we talked about earlier, right? There's two ways you can do this. We have a byte array, right? We have a giant byte array. Let me make sure this is going to be okay. Give me a moment here. Okay, good. We have a giant freaking byte array that we have to iterate through 1 byte at a time. And what if this byte array was storing a 4-byte color, right? Do we really need to iterate through this byte array 1 byte at a time? Can't we maybe optimize that a bit, right? I mean, you could keep it a byte array. Of course, we could turn this into an integer array of, we will 8480 divided by 4, right? Copy that. We could turn this into an int array, which gives us less loops through, right? This will give us less loops through. This is going to loop through the same way. This is now an integer. There's some other things you're going to want to do in here. What can you do now that you have bytes is not a byte, right? This is an int. You can then do some manipulation of the integer however you want. And then, of course, in here, we can get back to an integer array if we want, right? And the great thing is, from an integer, we can cast this whole thing to a byte array. It just gives us more flexibility when we use unsafe, right? Because now we're using pointers. We can do pointer casting without having any type of weird conversion going on, right? So we could do a, within each pointer, we can get a byte array is equal to the pointer. Dereference that to an integer, cast that up back to a pointer of a byte array, right? Just like what we can do in C++. We can convert every integer into a byte array. You can then do what you want on each byte, right? Then we can do b pointer plus 0. Dereference that is equal to 0. We can access every byte of the int, right? Very simply, very easy to read. That's all I'm saying. Would this be a proc Pigeon King? Yep, you could definitely do that. You don't need a... That's one way to do that. You don't need to do that cast back up, though, Pigeon, right? There's all different ways we can mess with this, right? But my point is, using unsafe is not just to get rid of bounds checking, guys. Using unsafe does not just get rid of bounds checking. We can use unsafe to do all types of manipulation of our data. We just got to remember that we can only do this on specific types of data. It has to be value type data, cannot be a reference type of data. Any last question on using pointers? I'm going to still talk about a couple things with unsafe, but any pointer questions before I go back to full screen? Give it a moment. I'll give it a moment because of delay. And then we'll move on. Alright guys, let's move on. Let's do it. Excellent. Excellent. I'm going to go back to full screen here. Boop. Alright, so that was a little bit of testing with bounds checking, right? And we can see bounds checking has a pretty heavy cost. The more you use your... The more we use those indexers, right? Next thing, and this is still within the concept of unsafe, guys, but this is around memory. We're going to talk about some memory stuff within garbage collection, right? Has anyone out there ever used the stack alloc keyword? Anyone out there ever use stack alloc? Stack allocators in C#. If not, I'm about to show you how to use it. Very, very simple stuff here, guys. Let's create a test method. Let's go create another test method here. We'll call it public static int, which is we'll call it test new stack, right? I want to be able to take in a size. So for this type of test, for because of micro benchmarking, I want to make sure the CPU cache is going to get thrashed. So we're going to pass in some data for our measure. So we have a new stack, right? What am I talking about, a stack Alex? Well, let's talk about this. Some numbers equals new int of size. Let me type this first, and I'll describe what's going on in the runtime for this function, right? We want to iterate through. Some numbers dot length plus I. And then we just want to say some numbers of I equals value. This is how we thrash the CPU cache to make sure we're not getting weird benchmarking data that we don't care about. We want to make sure we just get pure CPU numbers. Okay, so we have a little test here. Let's go measure. So what's going on here, guys? We have a value type here, right? It's like, why are we talking about the stack or heap or anything like that? We have a value type, and if this value type's never leaving this function, this should be step on the stack. What do you guys think? What's going to happen? Is some numbers going to stay on the stack, or is some number variable going to be a heap object? And anyone asking if if the stream will be available offline? Of course, guys, it'll be available as a highlight. It'll be available on Live Coding TV, and it'll be available on my YouTube later today. Don't you worry about that, guys. So, what do you guys think? What's going to happen? Where's some numbers going to live? It's Sean, it's assigned to the heap. Callister, it's assigned to the heap. Absolutely, guys, right? While int is a value type, and an int alone, if I just did int x equals 0, this would live on the stack, right? This, of course, would live on the stack because it's a value type. It's not a reference type. It doesn't go to the garbage collector. It's a value type. However, since we're doing an array of integers, this ultimately is just an array of ints, right? And an array is a reference type. It is not a value type. So an array of value types has to live on the heap, right? This now becomes heap data, which has to get tracked by the garbage collector, and it's heap data, so it's going to go through Gen 0 and Gen 1 and Gen 2. This will probably stick around in just Gen 0 or maybe Gen 1 since it's short-lived and it's going to go away, but it still has to get cleaned up by the garbage collector, and that has cost, right? That has cost. So let's go run this. Let's go see what that cost is going to be. Let's go see what's going to happen here. Because, you know, we want our baseline, right? Let's get a nice little baseline. Reps, as always, 5. Because we like our reps. It's a good number of times to get a good average, I think. We want to do 4 int I. I should wrap this as its own lambda, or its own function. But who cares, right? Let's do this 10,000 times. I like that, 10,000 times. It's a nice round number. Then we want to run our test new stack. We want to pass in this array size. Let's say 50. And we're going to try some different array sizes, guys. And in fact, I'm going to extract int array size equals 50, 1, 2, 3, because we're gonna try a few different test cases. And I'll explain why, because it comes down to memory. And maybe this is something you guys don't know about the garbage collector. We'll get to there. And we just want some random data that I want to pass in, right, for our value. This is what's going to make sure that our CPU cache stays corrupted for any type of caching, because I don't want to go to the CPU cache. It will... Whenever you do micro benchmarking like this, guys, you got to be very careful about CPU cache problems. Because you don't want the CPU cache to kick in, unless that's what you're benchmarking. But we're not benchmarking that right now. Let's go make sure this runs and see what kind of data we get, right? And I'm going to reduce array size here in a second. I just want to see some data. So on average, 861 milliseconds. Let's just go to 5,000 iterators, right? 40 milliseconds. Okay, we'll start there. We'll start there. So now, this is heap data. Garbage collection is going to happen, right? So let's make sure we get our GC collect in here, GC wait for pending finalizers, GC collect again. Make sure it's a full collection pulse there, okay? Stack allocate, guys, stack allocate. I'm just going to copy this function. We're going to call this stack test stack. What do I call this? Test alloc stack. That's fine. Whatever we want to make this, right? So what do we do? How can we maybe fix this? Because if we notice, we have an int array. This int array is not going anywhere for whatever reason. Why always have a function? This is I can't even think of my words today, guys. You know, it's a fake test. It's a fake test. But there are plenty of use cases where I need to initialize some data set. I need to work through something, and then we're going to get rid of that data set. We don't need it anymore. It's just some temp data, temp storage that we need. There's all different ways we can use that. But we can make this unsafe. We love unsafe because unsafe gives us pointers, and along with having pointers, we can now also use a very awesome keyword called stack alloc of int of size. So you can replace new. You can replace the new keyword with stack alloc, and instead of it returning an array, it will return you a pointer, right, like we've used before. And we'll return you a pointer like we've used before. Obviously, now we can't use length here, by the way, because this is not an array now. This is not an array. This is just a set of numbers. But now that this is a pointer, oh, I'm sorry, first of all, stack alloc, it's going to initialize this array on the stack. It's going to bypass garbage collection. It's going to bypass the heap. We're going to allocate this array of integers on the stack. Now, because it's on the stack, we can, again, only do this for value types or structs of all value types. You cannot do this for reference types, right? Because, again, you can't even get a pointer to a reference type. It doesn't work like that. So as long as you're within those bounds, you can do this. And now we're going to get an array that bypasses garbage collection. It's going to be on the stack. You got to be careful, though. Remember, by default, .NET threads, the .NET default stack size is 2 megabytes. Careful what sizes you're using if you use this. You can override that, by the way. You can have a bigger stack size or for your threads or for your main thread if you want. But you got to be careful with that stuff. With those warnings said, this is still something you can use. So instead of using length, we just have to use size here. And we can even rewrite this, right? We can even rewrite this. We can say some numbers plus I, dereference that, is equal to value. Not only are we using a stack allocator, But now since this is unsafe, we're also getting around bounds checking, right? And we'll leave this bounds checking here because that's fine. All right. Let's make sure it compiles and runs. We need to measure it now, guys. Now let's measure this. Let's call this stack alloc. Test for stack alloc, right? Exact same parameters. Let's see what happens here. Let's see what happens. So what the heck's going on? At a low count, at 5,000, our stack alloc is actually slower. Should that be happening? Should that be happening? Did we do something wrong in here? Let me see here. Oops. Let's just make sure that we're in release mode, by the way. Okay, good. And if we use this, are we still going to have a performance issue? And we do. Okay, just want to double check, which is good. So, at a small array size, using a stack alloc is not showing a major performance gain, right? And the difference between here, pretty close. We might not see any gain at all. We got to be careful, though, because we are using... the creation of this data is not the problem with doing a test around garbage collection, and we'll fix this in a moment, but the problem with doing a test around garbage collection, newing objects, we have a non-deterministic garbage collector, right? We have no notion, we have no idea when garbage collection is actually going to happen. All we're doing right here is newing up a bunch of new objects into the garbage collector. We're not able to properly measure when that garbage collection happens, or maybe we can. Maybe we can. We'll go check that in a moment. But that's one problem we have with this type of test, right? But we can ramp up our array size and maybe see something else start to pop through here. Let's see what we get when we start ramping up array sizes. And we'll ramp things down. So we can see that as our array size increases, well, what's going on now? Since we're adding a larger chunk of memory into the garbage collector, now we got to be careful. Now the garbage collector is having to start to work sooner to clean up because we're getting more pressure into the garbage collector, so it's going to have to run a little more often. And because it's running more often in that baseline, it's going to have to pause those threads. It's going to have to collect that garbage. And that's why we see a performance hit now happening. Of course, when a small size, you don't see a performance hit up front. However, you can see a performance hit in the back end that you're not even able to measure with something like this, right? Now, of course, if we... that was a large test, right? What if we kind of cut that down? It was about 16,000 integers. Again, we're still seeing about the same performance, maybe a little rougher. What about 24,000? At some point, you're going to see that we're going to cross a barrier here where baseline is a lot slower in stack allocations. And the reason that's going on, guys, if you do not understand how the garbage collection works in .NET, there is four heaps. There's four heaps going on, guys. There's generation 0, where all objects get created in generation 0. On a garbage collection pass, any objects that are still alive in generation 0 will get promoted to generation 1. On another garbage collection pass of gen 1, any objects alive there get promoted to generation 2. And they'll stay in generation 2 until there's no more references on them, right? So it's a promotional garbage collection. That's how it does its buckets, right? There's a fourth heap. There's a fourth bucket in the garbage collection. It's called the large object heap. It's called the large object heap. Any object that is over 80,000 bytes, 80 kilobytes, or greater will not go to generation 1. Instead, it goes to the large object heap, because the large object heap is a special bucket for objects. The Gen 0 cannot support objects of that size. Too much fragmentation would happen if you constantly allocating objects of that size in Gen 0. So instead it goes to the large object heap, which never gets defragmented. When objects get deleted, there'll be holes in there, and they'll be used if they can, but the large object heap just never gets defragmented, and that's just how it That's just how it goes, guys. So when I up our array size here, remember this is times 4 because this is an integer array. 24,000 times 4 is starting to cross our barrier of the large object heap, right? And I believe it's actually 85,000. I'm sure I'm mistaken. So anytime we have an int array over 21,250, so let's test this. Let's see. We'll see if we have right here, right? Our stack alloc up front is a slower execution, but remember the stack alloc is adding 0 to garbage collection, whereas our baseline is adding a lot to garbage collection. We're just not able to measure that up front right now because of no pressure, right? There's no pressure. It's hard to measure that. We will see that performance hit later in our application usage as garbage collections happen and we have no control over that, right? But as we spin this up to start to cross that large heap, that large object heap threshold, we'll see that the stack allocator starts to get better and better over the baseline. I need a calculator, but no. Yes, Sterling. So Niffle, you're talking about some latency modes. I'm gonna talk about that in a second, Niffle. I just want to know any questions on what I just described about how the garbage collector works with large object heaps. Why a stack alloc is starting to show better results than a standard initialization when we start hitting size barriers. And let me show chat. Let me get my chat up here, guys. Pigeon King, it's the total data. It's not code or data. It's the total size that you of your memory allocation, right? An array is not just size times 4. An array has some extra size at the beginning of the array to store the size of the array and stuff like that. Unsafe is thread safe, yes. Yeah, well, it's no more thread safe or unthread safe than standard usage. Hey, Jazz. All garbage collection in .NET is always non-deterministic. There are hints you can give to garbage collection. The garbage collection has an API. You can give it some type of hints, but you can never fully control the garbage collection. It is always non-deterministic. On and on, yes. And I'm going to talk about that right now, guys, but I'm curious if anyone has any questions about exactly what I'm showing right here. Let me check all my chat, sorry. For fair play change in test new stack for loops of numbers length to size. Sure. I will do this for fair play. Understand, though, guys, understand what I'm changing right here is not really needed. The compiler will take that length variable and store it in here. But absolutely, for fair play, I will absolutely do that. And as you can see, still a performance increase, right? Has stack allocation limitations affected your game's performance? No. No, stack allocate, it depends on your usage. You cannot override .NET's garbage collection for the large object peak, no. How can a computer do something non-deterministic? Frank, it's not that the computer is doing something non-deterministic, it's your software. The garbage collection is non-deterministic in the sense that you, as a programmer, have no control. You cannot determine when your objects will get released from memory, right? You cannot determine when the garbage collection will delete your object. That's what we say non-deterministic. That's what we mean. It's a different type of stream today, Ducky. We'll do some at the end of the stream, though. Okay. Let's talk about a couple other things. So, somebody asked in chat about latency modes. So with .NET 4.5, and that's what we're targeting here. There are some new hints. You could do a few things with garbage collection, guys. Garbage collection has an API. GC has an API, right? We could say collect. We could basically say, hey, garbage collection, I want you to go and collect right now. Don't wait until your normal mode. Go collect memory right now. There's a couple use cases for that. You really shouldn't be doing that too often, though, right? You can check where what generation object you're in. There's a lot of stuff you can do with the garbage collection API. However, you cannot. There is no way to override or fully control the garbage collection, right? Hopefully that's clear. Hopefully that's clear. All right, that's clear. With .NET 4.5, they added a new latency system to kind of give you a little more control over the garbage collection, right? I gotta remember. I think I have it somewhere in here. Oh, there we go. We could add system.runtime.gc settings.latency mode. We can have a few different latency modes. Interactive, by the way, is the default latency mode. It enables garbage collection concurrently, reclaims objects while the application is running. Concurrency mode was added in the GC a couple of versions back of .NET. And this is the default mode on a workstation. This is less intrusive. This is what you should be using most of the time, by the way, is interactive mode, right? And it's, interactive mode is our default. We'll just make sure that gets set back. So if we run this again with interactive mode, we should get the exact same results, right? We should get our exact same results. Cool stuff. We could go back to batch mode. This is the old mode. This disables concurrency, and it reclaims it. Basically, it pauses all your threads, does garbage collection, unpauses it. This is very intrusive. It has its uses, though. All of these latency modes have their usage. You just got to know when to use them. Let's see what happens if we use batch mode. This is the old garbage collection system. As you can see, our average time actually went up slightly. Our average time went up slightly. And you know what we could do? We could do a couple modes here. Let's not set that here. Set that before we do this one. So we'll have baseline batch. Oh, we'll call baseline interact. Baseline batch. We're going to try every mode. There's 4 modes you can do, right? So interactive, 2, and 3. We'll get them in here. Interactive batch. Low latency. Let's read up what low latency does. Oops, sorry. Low latency enables garbage collection that is more conservative in reclaiming objects. Full collections occur only if the system is under memory pressure, whereas Gen 0 and Gen 1 collections might occur more frequently. This does not mean, by the way, this does not mean that there will be less garbage collections. It just means that there will be less Gen 2 garbage collections unless there's memory pressure. There will still be plenty of Gen 0 and Gen 1 garbage collections. Now, when you're not running a garbage collection, guys, there's a reason why GC happens all the time. If you're not running the garbage collector, or if you're running it less frequently, you get more memory fragmentation built up in your in that bucket. And if there's more fragmentation, your performance for finding new allocations is going to be decreased. And we're going to see if that is true. There's also sustained low latency mode. Enable garbage collection that tries to minimize latency over an extended period. So low latency says, hey, I want to use low latency, but I'm only going to use it for a short period of time because it almost turns off. It will basically turn off Gen 2 collections unless there's no other option but to allocate a Gen 2. You might get out-of-memory exceptions if you have low latency on for too long. You got to be very careful with it. Sustain low latency, it says, hey, you can kind of do low latency, but for a longer period of time. It will still do Gen 0 and Gen 1 and concurrent Gen 2 collections, but it won't full block it'll only full block if it's under memory pressure, right? So there's also sustained mode. And then we'll go back to interactive here, right? So batch, interact, sustained, and low. right? So interactive, batch, low, and sustained. I'm not looking at chat. Sorry, I was working on doing that. Let's see what happens. Let's just run this. Let's see what data we get. Uh-oh. Uh-oh. And as I said, if you're not careful, you're going to have an out-of-memory exception, right? So interactive ran, batch ran, and batch is a little slower than interactive. That makes a lot of sense. Let me catch up on chat here, and we'll go fix this. If we put GC collect in the it would impact the runtime. We'd still get false poisoned results. But anyway, let's go fix this, right? And the only way to fix this is we have to reduce the size of our object, right? We literally just ran out of memory in generation, right? And that was under low latency, right? Because we turn off all, it's not really turning off all, but it's, for the most part, turning garbage collection almost completely off. It's not able to collect anything. It's not able to defrag anything. We get a lot of problems here. But now let's look at our results, guys. Oh my God, our results are in, right? Interactive, good results. Batch, slightly worse, as expected. Sustained, by the way, is better than batch, but not as good as interactive. Well, what the heck's going on here? I thought we could turn off the GC and get some performance improvements. That's not what this is for, guys. You do not use latency modes to get performance around this. Very special use cases to use latency mode. You should almost never use them, is my suggestion. Never, ever set a latency mode. You will probably hurt your performance. And in fact, when we use low latency, it's the worst performance out of the bunch. This is basically saying, hey, .NET, don't do any garbage collection. And for that, you get worse performance, right? And the reason you're getting worse performance is because in our low latency mode, we're doing a ton of object allocations. You only want to use low latency mode, guys, or sustained low latency mode. You only want to use these two in small blocks of code where you're not doing any allocations. You're just doing hardcore processing, right? If you're doing extreme processing, you're not doing any allocations, you can use low latency mode or sustained low latency mode to prevent that processing from being interrupted. And we could probably do a test for this right now while that's because of garbage collection, right? I need collect before low latency. We can put in a collect. We actually do have... Okay, let me add a collect. We'll add it, sure. It's still going to give us the same results, though. So interact has one, low latency. Sure, we'll rerun. We'll probably get the same results, though. As we can see, pretty much the exact same results, right? Sustained, low. All right, so low now is slightly better, which is okay. But the use case for, let me rerun this, right? Use case, so now we're getting about average results. And as we start increasing this without crashing, we gotta be very careful. Okay, good. So now we're seeing a low have slightly better results, which is good. It's still not as good as a stack allocation. However, you can definitely get good performance out of using the low latency modes if you know what you're doing. But only make sure you're using this, guys, if you're not allocating memory. These are not intended to get around memory allocations, right? Low latency modes, or the latency modes, are intended to say, I have a block of code that I want to run extremely fast. I don't want garbage collection to be an issue while I'm running this block of code. So let's turn off garbage collection. If you're doing game development, you can consider turning latency modes on into like low latency on when you're in your render step, possibly, right? So in that very short burst of time, you're doing your render step, which should be 1 millisecond, 5 milliseconds, 2 milliseconds long, whatever it is. Low latency mode is good there, and then make sure you turn it on and off right around that. Okay, that's latency modes. That's good stuff. We talked about stack allocations, right? Stack allocations have some good uses. Even at low block sizes, guys, a stack allocation is still going to be faster over the course of time than doing a normal new allocation, as long as you don't need that data outside of that function, right? Because you can't stack alloc and use it outside that function. However, you can, what you can do, by the way, if we have a stack allocation, you now have an integer, you now have a pointer, you can actually pass this pointer into a function call. You can say, you know, other func, some numbers. You can pass this in to another function to use your integer, use your stack allocated data, because we're in our stack, right? We are still in the context on our stack frame. We still have this data. We can pass it around as long as you realize as soon as you exit out of this context that this is going to go away. So don't ever store this pointer anywhere, but you can create this pointer as a stack alloc. You can pass it around to other functions and other classes. You can operate on it. That's awesome. Just remember that it's going to go away as soon as you lose state, as soon as you use your context here. Any questions? Any questions before we move on to something else? Let me make sure I show all, I can read everything here. I'll give you guys a moment. Can you use pointers in class scope? Within a function, as long as the function is marked unsafe, it can take in, they have in parameters of pointers, yes. Pigeon King, thanks for bringing up thread local storage. And yes, one thing, by the way, guys, we can use thread, if you don't know what thread local storage is, guys, let's talk about that real quick. Thread local storage. And thread local storage is very, very easy to use in .NET, by the way. So I'm going to remove all this code, guys. We're done with all this, right? We're done investigating. Thread local storage. What the heck is thread local storage? Let's create 2 tasks. T1 equals new task factory. Oh. I don't want a new. And we'll start them up, right? I'm going to create 2 threads. And I'm going to create some static int thread data. And we'll keep it like that, right? In our task, in each task, I just want to say thread data is equal to int counter. We'll keep it outside here, right? Counter plus plus. Well, no, we'll say a counter plus. Say counter, and then we'll increment it here. Let's just do it explicitly. Sorry, I want to make sure this is correct. So if we create 2 tasks, right? And this is... What the frick? I will understand. Oh my god. Giggling, thank you so much for that. We'll put that to good use, buddy. Thank you so much. Thank you so much. So here we go. We have 2 tasks, right, guys? Thread local data 1, thread local data 2. What's going to happen, by the way, if I try and write to this same static integer twice? What kind of data are we in? I want to do a console write line of thread data. And before I do that, I just want to do a t1.wait. t1.wait. And then we'll do t2.wait. What am I doing here, by the way, when I put these waits in here? Well, all I'm saying is I want to wait for both of these tasks to finish before I move on and write out what's in thread data. What's going to be in here, guys? We're starting up 2 threads. Is it going to write 1 and then write 2? Is that what's going to happen? Does it matter? In our little case here, we're probably always going to get 2. But of course, there is a chance that we could get 1, right? Because we don't know the order that these are really going to run in our little in our very simple test. The CPU is probably always going to run task 1 first and then task 2 first, only because that's just our startup time, right? If this was a little more complex, it's possible that thread 2 could run first and then thread 1. There's also the possibility that both of these could try and run at the exact same time and write to this integer. And that's okay, by the way. You're not going to get any type of weird deadlock. You're not going to get any type of error. You're not going to get any type of exception if 2 threads try and write to the same data at the exact same time. All that's going to happen is that ultimately one thread's going to write first and the other thread's going to write second, right? But you just don't know what order that these 2 threads are going to write in. So you have no guarantee what data is going to be stored in thread data when you have multiple threads running. That's why we put locking around stuff like this so you can guarantee what order things are going to get written in. Otherwise, you're not going to get any type of error. You just might not have the data you're looking for. So you don't have to make it atomic for concurrent writes, right? You don't have to make it atomic. You just don't know. You're just not guaranteed what's going to be in there. You're just not guaranteed what data is going to be there. So, if you remember earlier in the stream, if you guys were here a little earlier in the stream, we talked about memoization, right? We talked about memoization techniques and how we can just memoize around a concurrent dictionary. What if we have a scenario where we have worker threads calling a memoized function, right? And these worker threads, they have different data inputs and outputs, or expecting different data inputs and outputs. While we could have one shared concurrent dictionary across both of these worker threads for the memoized function, sometimes it might be more optimized to keep different lookup tables for each worker thread for its type of data, right? And then we can clean that stuff out when we're done. The easy way to separate that is using thread local storage. Exactly, Docsmari. Exactly. So with using thread local storage, you can have a separate data store for this variable for every unique thread, for every different thread you have. Every thread can have a different set for thread data, right? That means you can't use it across threads, but if it's not data you have to share across threads and you don't want to make it atomic or you don't want to make it shared data, right? It's just data I want to use within my thread for this thread. We can create thread local storage. So along with static, there's a tag we can put up here called thread static that you could tag it, and putting an attribute of thread static on a static variable will make this now thread local storage. However, there are considerations we have to worry about here. Because normally, if you want to do a static and you want to initialize your data to something, say you want to have a bool, right, that says, for whatever reason, you want to initialize it to false, right? If you use thread static, you can't do this anymore, guys. This will not, .NET will not run initializers on thread static data. So you have to be a little careful about using, I'm sorry, no, I don't want to use thread static. I want to use thread local. Oh, hold on. There's 2 things I want to use here, I'm thinking. Thread static and thread local, right? That's right. This thread static's the old way. Thread local is the new way to do it in .NET 4.0. To make that happen, this is how we do. This is how you should be using a thread static now, or thread local storage these days. You know, if we want a private thread local of a type int, right? Thread data equals new, And the reason why they did this is to get around that issue where thread static, if we choose the thread static attribute, it does not give us an initialization of our object, right? Because we can do a thread static of a reference type of an object type, but it's going to be null on every thread that first starts it up, right? But if you use a thread local wrapper, it gives you a way to pass a construction, an initialization lambda, to make sure that it gets initialized the way that you want. Right, so we can do a thread local of int, of thread data. This will only get called for every thread that needs to initialize this data, right? So here we can just return 0 if you want. Or you can do any type of complex initialization that you need. And now that we have thread data, well, how can I use thread data here, right? How do we use thread data in our software or in our task? Because an object reference is required for the non-static field. This needs to be private thread. I think I still need to make it static. Cannot convert type. Yep, there we go. Okay, so if you want to use this now, I believe there is a check whether the value has been initialized on the current thread, right? Because sometimes it's not, and you got to be very careful. Or you can just use value equals 1. That value equals 2. And now if I do a write line on thread data here, we can see that it's still 0, right? We can still see it's 0 because each thread in our main application is a thread, right? Because here we have 3 threads, task 1, 2, and main. Main has its own copy of thread data and thread local storage, while task 1 and task 2 have their own copy. So now you don't have to worry about concurrent data usage, right, on this thread data, on this static data, for whatever reason you might need it. And the reason why you might need this, by the way, is say you have lookup tables that you want to store statically. You don't want to have to reload it for every task that I launch. I just have some lookup table data. We can reuse that lookup table data on this thread, right? You're not necessarily going to use it for tasks because tasks come from a thread pool and you don't know what thread you're coming out with. But if you have your own task, if you create your own threads, right, you can control what function that thread executes in a worker sense, and you can then reuse the thread local storage of that thread over and over again. Does that make sense, guys? Does that make sense? Hopefully that makes sense. Let me show chat. Oh, chat's still open. Okay, good. Blade, we're doing some... I'm just going over some advanced C# techniques. So thread local is a variable, right? The variable type is a thread local type. This is a generic class. If we look at that, right, it's a class of thread local. It's a generic. It takes a type. We want to make it static. And this just wraps us around thread local storage. And this is just a way, thread local just a way, right? You can Google thread local storage. It's a very common concept. But this is just how in .NET, in C# we can use thread local storage very easily for our threads. Okay. One last thing I want to go over today, guys. One last thing, because obviously there's not... I can't just keep going over like crazy .NET C# techniques all day long. Even though we've been here quite a while, so that's cool. Weak references, guys. Weak references. Show of hands. Anyone out there ever in their life in .NET used a weak reference? Anyone in their life in .NET ever used a weak reference? Let's hear it. I'm curious. Super duper curious on this one. I can't see your hands. Raise your hands, everyone. I can see them. I can see them. Put those hands up. You don't even know what it is? Right on, okay. For object pulling, good. Pigeon, I love you, Pigeon. Almost used them, okay. Oh, Fallen Maverick. Alright guys, let's go over weak references then. Let's jump into some weak references. They're extremely simple, and that's why I love them. I love me some weak references. And someone in chat gave us the reason why we should use weak references, and I'm going to show you guys. Let's construct ourselves a little test here. Not a test, a scenario here, guys, right? Say we have an object manager. I want to create an object manager. Let's just go create one. Public class, I'm going to call it manager, right? Public class manager, and it has a private list, because it's an object manager of object, right? Of items equals new list, right? It's cool. We now have this object list, and void add. I want to add an object. I want this object to start getting managed, or be not even necessarily managed, right? Maybe this is just a class that uses these objects for some reason. Items.add. And one case you can use this for, especially in game development, if you're using like entity type component systems, and maybe entity component systems, maybe you have some type of inventory manager, which just has a list of all the objects that implement an inventory component, and you want to do some type of pulsing or some type of every game update. You want to iterate through this list and work on it as just some sample or some reason, right? So you want to add an object to say, hey, all right, well, I also need to be able to remove an object. And why do we need to remove an object from this manager? And we'll talk about that right now in a second. Let me just finish this. And this will, we'll talk about why we need weak references. And let's have a pulse, right? Pulse, we'll call it pulse, we'll call it update. Make it simple for you guys. For each, var o in items. Let's go through every object. Let's just do a console write line. You know what? I want to create this differently. I want to create public class test. I want my own test object because I want some data on it. Public int data. And now let's use this instead. Because I want to say o.data. I just want to write out, for every object in our manager, every update function, we're just going to spit out its data, right? I just want to spit its data out. Very simple. Very, very simple. And initialize that, okay. Okay, so now in our main, let's create a function here. Public static public void add to manager test object O. All within our scope. Okay, good. And I want to create a static manager mgr equals new manager, right? We're going to create a static manager class. I want a singleton, right? Ultimately, it's basically what we're doing, right? I just want a static object of that manager dot add o. Cool beans. Actually, I don't even want to do that. I just want to add to manager. I want to create test object of o equals new. For whatever reason, somehow we're getting a new object into our manager, right? So in here, I can just say add to manager. We'll add 3 times. And let's say o dot data equals counter plus plus. So I'm going to add that to static int counter start 0. Get some unique ID in here, right? I just want to get some unique ID in there. Okay, good. So we add to manager, and I'll do while true manager update console thread.sleep, just so it's not spamming here. We'll do this every second. Just so you can see what's going on. Okie dokie now. Okie dokie pokey wokey. Alright, so what are we doing here, guys? We are creating some objects somewhere, we're adding them to this manager, and then we're just going to have a forever while loop, right, that just dumps out our manager. And if we look at what's going on every second, right, we're just dumping out all these objects, Well, what if these objects that we're creating, let's do this this way as well, static public test object, new object, which is just going to do this, return O, right? And now let's just put this back to test object of O. I just want to add it to our manager, or even better, we'll not even use this. We'll just say mgr.add new object. The case I'm trying to get at here, guys, is while we have this object manager, this is a manager for a specific use case. Maybe these objects are owned by something else in our system, right? These objects can be owned somewhere else in our system. We don't care where they're owned. And if we consider the ownage something like this, right, we can say var o1 is equal to new object. 2 and 3, right? So now the ownership of these objects are owned by our main function. They're owned by main function. We just want to have this manager know about them as well and use these objects. Excellent. If we still run it, everything will still work the same way, right? What happens though is, like, I'm done with these objects. I don't care about these objects anymore. What happens if I O1 of null? Right? I want to tell my scope that I'm done with these objects. What's going to happen? What's going to happen? Are we actually going to delete these objects from memory? Is garbage collection going to collect these objects? Let's pull chat up. Let's talk about this. So we've nulled out our objects. Why? What's going on? Why are we still spitting these out to the console? Why aren't these objects getting collected by garbage collection? Right, exactly, Ages, right? Exactly. All we've done is we created these objects. We're the owner of these objects and say, hey, I'm done. I want to delete these objects, but remember, non-deterministic garbage collection, right? There's no explicit delete that we can call. We just want to say we should be deleting these, but we passed a reference to all these objects into this manager that's just trying to do some operations on these objects, but now this manager has a reference to every object we pass to it via this list collection. So this manager is a GC root, so root object, and it has a reference to everything, so the garbage collection cannot remove these objects. Even though we're done with them, the only way to fix this, of course, would be to say mgr.remove when we're done with our usage here. When we want to delete these, right, we have to call remove here. And now if we run this, let me close all this down. And close that down. If we run this, obviously there's nothing to dump anymore. The manager has nothing to work on because we've said, hey, stop tracking our reference to this stuff. But this is horrible. What if we have 20 managers? What if our software, for whatever reason, has a dozen different managers for different usage, and there's one object maybe gets passed into every manager, or maybe it gets passed into 3 of 20 managers to do some operations on it. And it's like, I want to delete this object. You have to now remember or track what managers all this object is located to, and go tell every manager to say, hey, stop tracking this object, right? This is not redundant. This is just explicitly telling the garbage collector that, in my context, I'm done with these, right? So how can we maybe fix this so that I can still null these out so that when garbage collection happens on these objects, because I don't want any more references to this, I don't want this manager to hold a hard reference to my object so that it can get garbage collected when I'm explicitly say I don't want this anymore. When garbage collection kicks in on that object now, they can get removed from this manager. That's right, Noxmari. So we can fix this, guys. We can fix this. Let's create a new manager class. Let's create a new manager class. Let's call this a weak manager. And instead of holding a list of test objects, we can hold a weak reference of test object. So the weak reference type is a object type, right? It's a class. It's a generic class of a type. So let's take this. And weak references are an awesome thing that the garbage collector supports for us. It's going to give us a weak reference to an object, not a hard reference, right? Not a long reference. So we have a weak reference. We're going to pass in our object still, but instead of storing O, we're going to go create a new weak reference, new of, and wrap it around object, right? And that's what we want to store. We no longer are going to support a remove. We could add that later. That's not important for our test here. We don't need a remove. When we're iterating through objects here, when we're going through the update, remember, items is now a weak reference. Is now a weak reference of test objects. And then in here, we can say var O is equal to the weak dot get. Give me a second, I'm trying to remember. Whoa! Apparently, somebody wants to have some fun here. Sorry, that's our set target. We need to... all of a sudden, my mind is blinking on me. Try get target. There we go. Sorry. Try get target, right? So we want to say test object O. We want to try and get the target of O. This is an out parameter. This is like looking it up in a dictionary. If you notice, this is going to return a bool. Tries to retrieve the target object that was referenced by the object, right? So we can say, if we find the weak reference, if we find the object around the weak reference, we'll continue operating on it. Otherwise, that means this object has been deleted by the garbage collector. All we have is this weak reference. Remember, weak reference is still an object itself. We want to make sure it gets removed from our items, but we also want to say console dot write line object has been deleted, just to give us a signal that, hey, it happened. And there's better ways to implement this too, but I'm just going to say weak ref of test, of test object, delete list. Right, let's just create a simple close that up properly. Create a simple delete list. Let's add our weak reference on here, because what we want to do is after we're done, we want to do a for each. Weak in delete list, and just in items remove, because we need to stop tracking this item, right? If the garbage collector right here, this test, the garbage collector tells us this object is gone, it's been deleted, there are no more reference to it. We just want to make sure our collection gets rid of our weak list, our weak reference, because we don't need it anymore. We don't need to keep checking for it if it's been, we just need to do a check one time, right? Here, but so all right, let's take a look, guys. So we still have our manager. Let's create a second manager. Let's call this our week manager, because we're having fun here. Week manager. Right, so we have a week manager. We have this manager, dumping manager. Fine. I want to wrap this into two functions now. Static void test manager. Give me a moment here, and then static void test week manager. I can't type anymore. Let's move all this code into our test manager, and we don't need to null this out, right? So remember, since we're creating a new object here, as soon as we leave this scope, if I was to not do this, if I wasn't to do this, we'd create new objects. As soon as we leave this scope, there's no more references to it, so the garbage collection will delete it eventually. But we're fine here. Excuse me. And then we'll have our while true. We'll dump the manager. And then we will dump the week manager. Let's see what happens real quick. Because we're not creating anything yet, right? We're not calling it, so make sure that was fine. So we can test the manager. So if we do this, we now have, every time we dump the manager, we have our three objects, right? They never go away. So what happens if we, instead of adding them to our manager, what if we create a week manager? What if we create a week manager? And so we're creating three new objects. It's not the same objects here, right? We're going to get 1, 2, 3, 4, 5, 6. And the 4, 5, 6 will be added to our week manager. And if we run this, I'm curious if we will see them at all. So, okay, I'm thinking how we'll probably do this in a thread, to tell you the truth. And then that's when we'll null these out. Or maybe not. We should get one iteration, right? So here we go. Let's make sure I'm going to set this up correctly, because I'm failing to do something here. We're not nulling out our data. I shouldn't need to do this. We're holding on to a reference in here. And I'll fix it right now. Test our week manager, right? Week manager update good. New object returning. Test week manager. We should be fine. I need to, for our test purposes here, oh, we need to do a garbage collection. I'm sorry. So what's going on, guys? It's working as intended. These objects are going out of reference, but remember, we're adding no pressure. .NET doesn't just run the garbage collection constantly. It only runs GC when you allocate new data, and then there's pressure. Since after all of our tests here, there's no more data allocation going on, right? There's no more data allocation going on. We're also not adding any pressure. One way we can do this, we can say var x equals new byte 1,000, and then say x dot 500, just so that it doesn't get optimized away. This might cause some pressure eventually as well. Let's see what, I'm curious. I don't know if it will. But we could just force a garbage collection too, by the way. I was just interested. Okay, so we could also then just say gc.collect, force a garbage collection. I know there's no pressure, there's no objects being allocated, but I just want to force a GC, and there we go, right? So if we go back up here, we can see that a dump week manager, first iteration through, 3, 4, 5 was great. Because remember, non-deterministic, even though we collected garbage right away, it didn't get deleted right away. But then the second time through, when we ran the dumping week manager, we detected that all of our objects have been deleted because we're collecting those now. If we look at how it's running here, the dumping manager still has all these references, and our week manager has nothing, right? We never had to call We never had to call remove on anything because we're just using weak references. Anyone, any questions on that, guys? Are there any questions on weak references? I know it's kind of a weird concept, but I think it's pretty simple concept for people to figure out. Why would it ever be better to use a weak reference instead of a normal reference? Ajaz, use weak references if the container, if the class or the object that's using that reference is not going to manage that reference, right? Use a weak reference if you want to have something where you're not managing that reference. You don't care about that reference. I just want to use this object until the object doesn't exist anymore. So if you're not going to manage the reference, use a weak reference. The best place it's used most often in .NET UI work is in event notification, delegates and event notification. When you register an event to a delegate, that becomes a static, how .NET binds that stuff up, it becomes a pinned static event. If you use weak references, you get around some horrible things. And exactly, DocSmart, it's all about ownership, right? If you don't intend to manage that object. DocSmart to the rescue, everybody. Well, guys, everybody, that's kind of everything I have for that I was planning to show you guys for today. I also wanted to go over coroutines. I just didn't have time to really set up some fun stuff around coroutines, but you can go read on the internet about coroutines in .NET. They're pretty cool. It's a pretty decent implementation on how they implement coroutines, but I didn't want to get into that. Refs are also good when objects are expensive to create and you want to minimize creating new ones. Pigeon, you got to be careful about recreating weak objects that have been deleted via weak references, but you have a point, yeah. So last thing, guys, last thing I'm going to do, in case anybody is curious. There was two utility functions that we created. I'm going to do some Steam game raffles, guys. Don't run off, by the way. I know I said I'm done. Don't run off, though. You have a chance to win some Steam games for hanging out here. I have created already, let's show all files, some of this stuff. Right, here's our fast object allocator, all documented out for you guys. Our memoization system, all documented out for you guys. I'm going to go set this up in GitHub right now. I'll do it live on stream. Let's do this, guys. Let's create a new repository. Call it utils. It's going to be public. I want to create a blank repository. Let's go push this, guys. Let's go push this, yeah? I need to add a remote push to. I want to add a remote. And we're pushing, guys. If we refresh this now, I got to push. I actually have to do the push. Got to configure it. Got to log in. Hold on. Give me a moment. Now, if we refresh this, everyone, there you go. If anyone is curious, if anyone is interested, I will paste this all over the place. If anyone is curious, there you go. If you go check that out, guys, have fun with that. Have fun with that. It's not a lot of code, but it's some pretty specialized code, some pretty cool code. So if you want to use that, that's great, guys. Let's fire up. Yeah, let's fire up some Steam game raffles, everybody. Thanks for hanging out with us today. I want to thank you for showing up. I want to show my appreciation because of how cool everyone is. I'm going to start it up right now, guys. If you're out there, guys, if you're reading my voice, if you hear my voice, get into one of my chat rooms, guys. Get into one of my chat rooms. Say one thing in chat. Just say one thing in chat. and you'll get into our Steam Game raffle. The bot just has to know that you're active. As long as the bot knows you're active, you will get into our raffle, and we'll raffle off a few games here. We have a huge list of Steam games. Huge list of Steam games, and we'll give you the link so you can go look at the gift library directly if you want. And this is how we do it, guys. We do Steam Game raffles all the time around here because I love you all. Because I love you all. What's that, Blade? Since you're talking C#, anyone know of a good way to disassemble iOS Android apps? Oh, good question. Get in the raffle, guys. We'll pull a few names. We're definitely going to pull a few names. We'll have some fun. Oh, I also have a few more games available that are not in my Steam Game gift library. That are not in my Steam Game gift library, which is up here. Absolutely up there. And we'll pull, 3, 4 names, guys. We'll pull like 3 or 4 names. B-Jerd, how's it going, B-Jerd? How you doing, man? And by the way, anyone who joined the stream late, anyone who didn't catch the full stream, right? What do we hear? About 4 hours, see 7, 8, 9, 10, 11. Yeah, about 4 hours. But we did about a 4-hour stream, right, guys? So if anyone missed out on anything, if you joined in late, I will have a highlight set up for it on Twitch soon. It'll be auto-archived on Live Coding TV, absolutely. And then I'll upload it to my YouTube from my local copy. I'll probably cut out some beginning and some end stuff just to make it nice and streamlined, and I'll upload it to YouTube like I always do. We'll see. But it'll be everywhere for anyone to go check out. Don't you worry about that. Meller, I do all types of streams, all types. Will you continue the C# tips and trick thing later? Malapropos, I don't know, maybe, if I can think of other C# tips and tricks. I mean, I know plenty. Some of them are more advanced and some of them aren't as cool. Eric Gattakat, I'm sorry, I butchered your name. I stream 7 days a week. Most of our streams, though, I'm doing game development. I do video game development for our projects. Every once in a while, I take a step back from our video game, from the projects we're working on, and I do streams like this. But you can definitely show up on one of our on any regular scheduled video game development, and we're here to help you in any programming task. So while I do stream the development of our video games, I'm also here to help people out, no matter what. No matter what. So while I don't do a learning stream like this, regularly, I think every time I stream, I'm hopefully imparting some type of knowledge out there for the world to see. And it's fun. It's fun hanging out with me. I think I'm fun. I got a big ego. Today, guys. I'm sorry. But we're gonna let the raffle build up a little here, guys, and then we'll pull a few names, 3 or 4 names. Pull 3 or 4 names. And actually, while you're doing that, I need to fix my alpha build. I need to re-upload it real quick. I just got to add a file in and then just re-upload it in case anyone out there is trying to play our game. And you're like, why is it broken right now? Because sometimes I'm a dummy, guys. Sometimes I'm a super dummy. Give me a moment. I'm going to just bake this in and re-upload. Thanks for the follows out there, everybody. Thank you so much for the follows. Okay, log in and upload. That should work. If I type my password correctly. There we go. There we go. I'll look in chat here in 1 second, guys. I just want to do this before I forget again. Because everyone who knows my stream knows with me and forgetting. Me and the forgetfulness. Okay. Thanks for all the follows out there today, guys. I appreciate those. Oh my god, I appreciate those. Every time. Every time. I'm going to get those names in a second, too, as soon as I can look back over there. Holy cow, they're flowing in right now. I wonder if they're all delayed from earlier. I have a feeling a lot of those are delayed from earlier, but I appreciate them. All of them. Okay, my upload is done. All right, guys, if anyone out there, by the way, we'll show you all the links in a second here. If anyone out there is curious and they want to play the pre-alpha to the video game that we've been developing for the last 70 days or so on stream here, you can click that link. You can, and you can go play it. You can go give us your comments. And remember, it is super pre-alpha, guys, super pre-alpha. So if it breaks, if there's bugs, if it's not fun, I take full responsibility. For the raffle, no, of course not, buddy. If you win a raffle, guys, if you win a raffle, just tell me what game you want, and we send it off to you. There is nothing needed, nothing needed. Any games that are donated to the stream, we just turn around and re-raffle them back off to all you lovely people out there. What's up, Dragon? If Jetty. And if anyone out there needs a link, I'm sure Docsmari has been taking care of links over there. But if anyone does need a link to my Steam game library, my gift library, if you want to see what's there, you can click that link. I put it up in a couple places. Let me copy this now. I'm just doing some setup here, some command updates, and then we'll get to some raffles. I hope you guys had fun today. I had a lot of fun. Showing you guys some C# stuff. I hope at least a couple people out there learned something today. I hope at least one person learned something. I think I blew some minds with our fast object allocator, though. I think some people were under an impression that generic knew of the generic was fast, when in fact it was the slowest of the bunch. Everyone. You learned trend? I love it. Gixon, yes. Good stuff. All right, mission accomplished. Mission accomplished. Once I get this uploaded to YouTube, guys, once I upload this video to YouTube, I will send out a tweet and let everyone know that it's up there. If you want to watch it on YouTube, right? Everyone prefers to watch offline videos their own way, so I have my videos in like 4 different places. So you have lots of choice. You can watch my stuff on Live Coding TV. You can watch my stuff here on Twitch if I create a highlight from it. And of course, you can watch it on my YouTube channel. No. In fact, Killamatani, is this a C# only stream? In fact, I rarely do see anything with .NET or C# on my stream. This is primarily a C++. Well, I wouldn't say primarily. I mostly do a C++ game development stream. I use C++, some scripting languages on top of our engines, primarily, right? But I like to branch out and show my viewers some new stuff every once in a while. You weren't aware of ILDASM until now? Well, I'm glad at the very least I could tell you about ILDASM, guys. How much time have I spent looking at ILDASM? I don't even know. If you guys aren't aware, most of you guys probably aren't aware, I actually, for my company, for my day job, if you want to say, I write and maintain we have a compiler. So we take a homegrown in-house scripting language that is used a lot in our application, and we actually cross-compile that to IL. So we basically take all of that ingrown code, and we translate that to IL, for us to compile and for us to execute in a native .NET context. We need more Godot. Meller, I can agree with you, man. I actually kind of like working with Godot. What was that, Jetty? I heard you about that. You already know you're gonna win Five Nights at Freddy 3. Was that comment, Jetty? What error do you get, Vins? And remember, it's Windows only, guys. Windows only. Docsmari is not a fan of Godot, by the way. Docsmari is so not a fan of Godot. What's this, Arnold C? Arnold C is the best scripting language, Berg. Arnold C is the best scripting language you will ever find. Oh, Jetty, absolutely, guys. If anyone out there is working on a your own game, if you're working on an indie game, you're doing some type of game development, if you're working on game tools, man, Jetty has a link right there that we're collecting all that stuff, all of the viewer collection of things, where all my viewers can hang out and talk about the games they've been working on. Oh, well, which you can, of course, do it on stream here. This is more for off-stream stuff. IO can compile the C++. Absolutely, AJs. We actually have a cross-compiler at my work. We already do this. So we take our ingrown, that ingrown scripting language, we cross-compile to IO, and we also cross-compile to C++. So we have 2 different versions of our code that we output. How do you enter C's? You just did. Vins, what error do you get, my friend? Caluk, how many languages do I know? A lot. I don't know. It's not a good question to ask me how many languages I know. Anyone who's worked with software for a very long time, Calo, it's like how many languages you know. That's not what's important, how many languages you know, because it's easy to pick up a new language. It's easier to learn the runtime of that language. That's not such an important question anymore. Dragon Meny's been awesome, buddy. How's it going, guys? Lormiz, hello, hello. Then vote on the best 1 or 2 and work on them. Oh my god, Massey. You got some great ideas, Massey. That would be awesome. We might have, Massey, we should do, we need to do Wilkie Jam at WilkieCon sometime this year. We're going to do virtual WilkieCon, and we'll have a virtual game jam. You're watching me twice, Birds? Oh, I love it, dude. My favorite languages, Calo. Oh, I don't know. C++ always has a soft spot in my heart, always and forever. I love that language so much. I like C#. I'm a pretty big proponent of C# and .NET in general, just the general ecosystem. After that, what else do I like? What else have I been warming up to? Python. I've been warming back up to Python lately with the Godot stuff. It's kind of grown on me again. And then there's some other types of languages, but those 2 probably C++, C#. I think I've probably if I had to pick my favorite children, maybe those would be it. Wilkie Jam, Massey. What's up, everybody? Yes, Valve. Yes. However, Valve, nowhere near our max viewers that we've had, right? Vork, you missed the entire stream, but you can watch it offline. Don't you worry. Can't wait for the cosplays, Jonathan. How many people are going to cosplay with a beanie? They're just going to wear a beanie. In my backyard, Doxmari. Eat barbecue, drink beer, play. Oh my god. Doxmari, let's do it. I have a barbecue and a smoker, Doxmari. I will cook up some meat for you guys. OMG. I'm sorry you guys did not get notifications today. Unfortunately, Twitch, guys. Twitch is Twitch, right? Unfortunately, Twitch is Twitch. Well, let me see what Vin's issue is here, guys, and we're going to pull our first name. Give me a moment. Vin's, interesting error you have there. I might have... Vince, I'm going to send you a message offline on Twitch and see if I can get your log file. It looks like you're having a problem with the shaders. And I would need to know what kind of graphics card you have, Vin. My favorite language is Pearl Dragon. Whoa, you found me out. You found me out. Zolfer, the game is hard. Yes, it's very hard. But are you having fun? Are you having fun with it? Are you having fun? That's what's important. How good is Mono for OS X? Mono is good stuff, Ransec. Mono is good stuff, man. I mean, it doesn't support the entire .NET stack, like WPF and all of WCF and stuff like that. But for general .NET development, Mono's fine. Yeah, Vince, it sounds like you're having a problem with our shader. And I would need to see your log file, and maybe that can help me isolate that, my friend. What kind of video card do you have, Vince? What kind of video card do you have? And while Vince answers the question, guys, let's do it. Let's draw our first name. We're going to draw like 4 names, so it's going to take us a little while here. So if you don't win on the first roll here, guys, if you don't win on the first roll, don't go anywhere. We're going to pull more names, and we'll see where we go here, all right, guys? First winner up. Make sure you're still here, guys. Otherwise, we re-roll after a while. Make sure you're here. But first winner up is Asvati. Asvati, are you out there? Please say something in chat. Next 90 seconds, I would love, love, love to give you a game. Love it. Make it happen, man. So who's been following us lately today? We've had a lot of followers. Lifer, B-Jerg TV, Shade, Coon, Pututo Pullman, Jojo the Slayer, Coder Dozer, guys. Thank you guys so much for following. Stereo Bram and Killamati. I'm butchering everybody's name. CSS Charles, Zopher, and Gillum. Oh my god, and Gillum an hour ago. Nice donation, man. Thank you so much for that donation. We will put that to excellent use. Don't you worry about that. Thank you guys for following. Oh my god, Asvati, you're here, Asvati. So please, Mr. Asvati, tell me what game you would like, and I would love to give it to you. If you need the link to my gift library, let me know, or just tell me, and we'll get it to you. Make it happen. We'll make it happen. Yeah. Alright, give me chat back up now. After I beat the game, I'll send a screenshot to show how awesome I am. Right on, RadLab. No, Anderson, you just made it, buddy. We just pulled the first name. You want Gunslinger. Ooh, Gunslinger. Where is... What is Gunslinger? COJ Gunslinger. Sometimes I have to find these games since I don't even know what some of these names are called or where to find them. Because we get so many games. Ooh, Call of Juarez. Absolute Asvrate. Ooh, let's do this, man. Alright, this is how this works, my friend. This is how this works. So first of all, congratulations. I need your email. If you could go check your Twitch messages, respond back to the message I just sent you with your email address. I'll have Steam email your game. Now make sure you check both your inbox and your other box and respond back, and we'll get you going here. And then we'll pull some more names. How do you check who followed you? My followers are coming from Twitch, Ingzoof, so I have an API for that. You know, call me Bjerk. Bjerk, I'm sorry. It's Bjerg. Bjerg. I apologize, my friend. I apologize. So, Massey, you fixed the pixel issue? Your half pixel issue? Did you fix it? Should you dibble at all the programming languages, stick with one, then go with another, and so on? Hyper, that's it's ultimately, man, that's how you whatever way you learn the best. Maybe dabbling in a bunch of languages will give you a better understanding of just how software is written in general, or how all these different languages ultimately come down to the same compilation, right? Or maybe you want to stick with one language and master all of the ins and outs of that language, right? So like today on stream we talked about some very specific C# stuff, while people out there maybe are experts in C# in my stream had no idea about the things that I was, or maybe some of the things I was talking about. So just because you know a language, or just because you're very familiar with the language, and you know it well enough to use it, doesn't mean you know every little bit of that language in that runtime, right? You can get 99. All right, Massey. Hope he gets the support he needs. I hope so too, Mass. Let me check my messages. Let me see if Azavate has responded. Oh, I got his email. Yes, sir. Yes, sir. Let me go send this off, and we'll pull another name right now. Okay, guys, that game is off. Please go check your email. Steam's going to be sending you one right now, Azavate. Get your email. Have fun with that game. Let me know how it goes, dude. I'm curious. I'm curious. All right, guys. Let's go. By C sharp, you mean C? No, I mean C sharp. I mean, when I say C sharp, I mean C sharp, right? All right, guys. Let's pull another name. Good luck to winner number 2 up here. Who's it gonna be? Oh my God, Meller 127. Are you out there? Chat. 90 seconds. Say something. Let's give you a game. Let's see it. Let's see it, man. Oh my God, Meller is out there, everybody. Congratulations, Meller. Your turn, buddy. Pick a game. Let's send you one out. Let's send you one out there, Meller. So anyone who caught most or all of the stream today, what was the favorite thing you learned? What thing did you learn that you were most excited to hear about and think you might actually go use? Azvate, congratulations, buddy. Oh my God, Meller is starting guys, the reroll train has started. The reroll train is here. All right, buddy. Good guy, Meller. Good guy, Meller. Absolutely, dude. We're going to reroll. Here we go, guys. Let's see what happens next. The next winner is, trust me, SC2. Are you out there? You're on the clock, 90 seconds. Let's see what's up. Say something in chat. Akaroma, hi from Russia. Hi from California, man. Hi from California. Memoization, nice. Nice, I like it. I wake up today and see this stream. Aw, there we go, dude. How the garbage collection works. There was some other stuff I didn't even really get to, Coder Does. I'm gonna ask you guys some questions about some garbage collection. Maybe I can demystify a lot of bad ideas people have about C# garbage collection. So in C#, guys, why we wait for Trust Me here, or if we have to reroll, because we're on the reroll train right now. In C#, we have the iDisposable interface, guys, right? We have iDisposable. iDisposable gives us a dispose method that we as programmers can call. My question to everybody out there in chat is with a yes/no: does the garbage collector call your dispose method? Does since you now implemented iDisposable, will the garbage collector call dispose for you? Oh my God, it's reroll time. I'm so sorry, trust me. Next winner up is Korigoth. Korigoth, are you out there, man? 90 seconds. Let me hear you sing in chat. No, just say something in chat. We'll give you a game, 90 seconds. Gilgam, yes. Pigeon King, yes. Someone thinks maybe. Lots of no's. And I don't know. I respect an I don't know, by the way, Osmender. There is no shame in not knowing something. It's better just to say you don't know, especially, guys, if you're going on a job interview, a technical job interview, please just fess up. If you really don't know something, just say, I don't know. I don't know. Maybe they'll teach you about it. Kirigoth, congratulations, man. Please let me know what game you would like, and we'll send it out to you. Dev Edsy gives us an explanate, gives us an expanded answer. I like it. So here is the answer. It also offers a lot of insight in garbage collection in general. Oh, right on, Valve. I love that book, man. So guys, the garbage collector, as most of you guys just said, is no, right? The garbage collector has no notion of interfaces. It doesn't know about iDisposable. It doesn't care about iDisposable. The iDisposable interface is just a pattern for us developers to use to dispose of some of our resources explicitly, typically unmanaged resources, right? No problem, Kilgroth. Just let me know. One-way heroics. All right, buddy, give me a second. And also, actually, Kilgroth, can you send me a Twitch message? Can you just click my name, send me a Twitch message with your email address, and I'll have Steam email you your game, my friend. So yes, the garbage collector has no notion of iDispose, right? So it's not going to free up. If there is no call in your code for dispose, it will never be called. And as somebody in chat mentioned, if you implement a destructor that calls your dispose method, then that way the garbage collector, when it's destroying your object, if your destructor has a dispose call, it will then call the dispose and do that type of cleanup, right? So the best pattern, by the way, around dispose is to make sure you have a dispose, wrap the dispose so you can pass in a true-false if it's basically you're calling it or the destructor calling it. If you're calling it, after you do your dispose, you want to suppress the finalizer. And what does that mean? What does suppressing the finalizer mean in garbage collection in .NET? Well, in .NET, if you implement a destructor, that's really called a finalizer in .NET. We don't call them destructors. They're actually called finalizers, right? They're called finalizers. So in the garbage collector knows about finalizers when it says there's no more references to your object. Let me check. This object implements a finalizer. I can't delete this object right away because we don't call finalizers on the garbage collection render thread. Instead, it adds that object to a list on another background thread called the finalizer queue, right? During garbage collection, the finalizer queue will execute, and through every item on the finalizer queue, we'll call the destructor, and then it'll delete it off the finalizer queue, right? So there's an added cost whenever you implement a finalizer or destructor. There's an added cost to garbage collection when that happens. However, you could tell the garbage collector that, hey, suppress the finalization of my object at any time. If you know you don't ever need it to be called, you can actually suppress the finalization. And where we usually do that is in that dispose pattern, right? If you implement a proper dispose pattern, you will call your dispose explicitly, clean up any unmanaged memory, that's fine. Suppress the finalizer because your finalizer should just have a call for dispose, right? You don't need to call that anymore. Otherwise, you should very, very rarely implement finalizers. What do you suggest regarding disposing when you're injecting disposable classes with things like Unity? Dev, just like I said, use the garbage gc.suppress finalizer. So if you are going to explicitly dispose an object, you can then tell the garbage collector to not call the finalizer on it, right? Where can I click on your name to tell your mail? If you can't find my name, I'll send you a message right now, my friend. Sorry, I know I'm not typing in chat, so you can't see it. No worries, dude. Need your email. So if you go check your Twitch messages, Koragoth, if you go check your Twitch messages, respond back with your email address. And check your inbox and your other box, and we'll get that off to you, my friend. We'll make that happen. Oh my god, Rise at TV! Stay because of big vocabulary and create. Oh. By the way, guys, if anyone out there is a Hearthstone fan, if anyone ever watches any Hearthstone streams, you should be checking out Ryzen TV. He's like the third most popular Hearthstone streamer in the world. But in my heart, he is the most popular. He's the most entertaining, I'll say that much. I want to see Ryzen with that crazy big winter coat again, Ryzen. Last time I watched you, Ryzen, you had that giant winter coat on in the middle of California, and you're nuts. Dev, yeah. I love you, Ryzen. I'm one of Ryzen's oldest subscribers, by the way. One day I'm going to be Ryzen's oldest subscriber. Ryzen, my last time I put in partnership, they said no. They don't. Twitch doesn't like me. Somebody at Twitch does not like me, man. Let me check my email here. Let me check. Oh, Korgoth, I got your email, buddy. I got your email. Let me send you some one-way heroics. And we're going to pull another name right now, guys. And let's keep talking about garbage collection, because I think there's so much unknown knowledge about .NET garbage collection that is easy to go find out. It's easy to find out there, but most people just, I don't know, maybe they just don't care, or they don't think they need to know it, right? .NET and things like Java and Python, they make it easy to write software, but with that easy to write software also means sometimes we get lazy about how we're using our software, how we're writing that software, right? I do it too. I do it too. All right, let's pull another name, guys. Let's pull another name. Game is sent off. Third winner up. Third winner up. And I got a couple more garbage collection questions for you guys. Here we go. Good luck, everybody. Winner is... Oh, my God, Blade. Oh, my God, Blade. Are you out there? Live Coding TV, Blade. Are you out there, man? 90 seconds. Let's hear it. I know you're there. You can hear my voice. All right, so we know now, right? iDisposable is not called by the garbage collector. It's a programmer interface programming pattern. Excellent. We also know that the finalizer, if you implement that, has a garbage collection cost. So be careful when you implement those. They have uses. Use them if you need to. Don't put silly stuff in a finalizer. Be very careful. Also, guys, extremely important, never, ever, ever initialize new objects in your finalizer. Never throw an exception in your finalizer. Your finalizer should be as basic as it can get, guys. Never do that stuff. Oh, my God. Don't new objects in your finalizer. Oh my God, Blade, you made it. You made it, Blade. What game would you like, Blade? What game would you like, buddy? What else can we talk about garbage collection? Does everyone understand Generation 0, 1, and 2, right? Well, first of all, everyone understands out there that .NET Garbage Collection is a generational mark and sweep garbage collection system, right? So, and when we see generational, that there's 3 buckets to garbage collection, right? Everyone understand that there is a Generation 0, 1, and 2, right? Anyone not know that? Do I need to explain Gen 0, 1, and 2? I will. I will if you ask. What's going on, Hustlin' Hack? I'm doing some raffles right now, buddy. Blade is very, very focused. What do I recommend, dude? I have no recommendations for you, Blade. Maybe chat out here. Maybe someone in chat. Oh, hold on. Is my... Oh, there we go. Maybe someone in chat will give you a recommendation. Guys, help Blade pick a game. Sure. Garbage collection. We'll ignore the large object heap, Meller. Yes, large objects go to large Gen 4. We're going to ignore that, though. Let's just talk about standard garbage collection, right? Standard garbage collection, there's Gen 0, there's Gen 1, and there's Gen 2. Gen 0, every new object you create, I don't care what size it is, besides large objects. I don't care what size it is. Every new object you create goes to Gen 0. It always gets allocated in Gen 0, okay? The reason we do this, Gen 0 is a small block of memory. It's a small list of objects. It's highly optimized for short-lived objects. So if you new up an object and then immediately delete it, usually in the same context, it's going to go to Gen 0. It's going to come right back out. Very, very fast, right? However, because it's a generational mark and sweep algorithm, when we add objects to Gen 0, the garbage collector is going to then kick in and say, hey, can I, first of all, is there space for this object in Gen 0? If there's not enough free space in Gen 0, that means we have pressure in Generation 0. Now the garbage collector is going to do its business, right? It's going to do its collection routine. It's going to go through all the objects in Gen 0, find out if any of them have no more references. Basically, when we say references, it has to have a GC root reference. Every object will have a tree that works its way back up to a GC root. If that object has no direct path to a GC root, we know that object can be marked for deletion, right? And it'll delete it directly, get rid of it, right? If an object has a direct path back to a root, basically something still in memory, it's going to, in Gen 0, it's going to move every object that is still referenced to Gen 1. We'll get to Gen 1 in a second, right? So every time we new open object, it goes to Gen 0. The garbage collectors say, is there enough room in Gen 0? If there is, it just adds it and forgets about it, right? If there's not enough room, it's going to, let's do the Foreign Legion. All right, give me a second, Blade. I'll send that off to you. Actually, Blade, can you go send me a live coding TV message right now with your email address, and I'll get that off to you. So if we add an object and there's room, it adds it, forgets about it, everything's cool. If we add an object to Gen 0 and there's not enough room for that object, it does its collection, moves everything still in reference to Gen 1, everything not being referenced gets deleted, and then it'll add your object to Gen 1, or to Gen 0, right? Now, Gen 1, when objects are moved from Gen 0 to Gen 1, when we're moving them over, they're getting promoted a generation. Now we're going to look in Gen 1, right? If an object's being promoted from 0 to 1, we have to do that same check again. Now we're in Gen 1. Is there room for this promoted object in Generation 1? If there is, boom. Adds, dones, moves on, right? If we're trying to promote an object to Gen 1 and there is no room, the exact same operation is going to run again. It's going to scan through every object in Gen 1, find the ones that are still being referenced, and then promote all those to Gen 2. Ones that in Gen 1, if they're not being referenced, they get deleted, right? They get cleaned up, and now we have a nice fresh Gen 1 where all the Gen 0 promotions can get dumped into. In Gen 2 now is our last step, right? Gen 2 is the last step, right? If in Gen 2, if we find that we are adding objects and there's no more room in Gen 2, instead of promoting from Gen 2 somewhere else, there's nowhere to promote to, it goes to the operating system and allocates a new memory page. That's all Gen 2 does, right? So Gen 2 will continue to grow and grow and grow and get larger and larger as you start creating more and more objects that are going to live for a long time. So Gen 2 allocations are the most, scans are the most expensive because they usually have the most objects that it has to look through, right? So the longer you hold on to an object, the slower and slower garbage collection might get. So once it scans through Gen 2, if it finds any objects not being referenced anymore, they get deleted, and we can then defrag. Oh, by the way, every time we delete objects from 0, 1, and 2, it will also defragment those heaps, those generational buckets, so that it keeps it nice and compact, right? Nice and optimized. When implementing ISOs, is there a way to avoid checking if disposed in every member? Pigeon King, no, there's not. But if you shouldn't be having an object around that you call disposed on, and you're still trying to use it somewhere. That's you have a bug in your architecture if you're doing that. Zero signal, I never breathe. This time with drawings, Docs Mari. All right, hold on, guys. I'm gonna go draw. All right, let me go check my email. Let me go send this game out to Blade, and then we'll draw another winner. Give me a second, guys. What, Foreign Legion, or whatever it is. What the heck? Oh, Foreign Legion. Right on. Multi-Massacre. Yes, sir. That looks weird. Looks like a zombie game. So, Blade, go check your email. Steam's going to be sending you a message. Get your game. Collect your game. Have fun with your game. That'll be a good game. I hope it's a good game. I hope you picked well, Blade. Let me check out. Let me catch up on chat here. I'll try to end Enderkin. Is it? Yes, it is humanly possible, Diego. Very, very hard. Guys, the mini-boss at the end of the demo right now is very tough. If you can beat it without cheating, I will give you something cool. Will the capacity in Gen 0, 1, and 2 get bigger if you use more memory? Only Gen 2 is really going to get bigger. And that's a general case, Ajez. There is some certain circumstances where Gen 1 and Gen 0 might get a little bigger, but in general, Gen 2 is what grows. QN, exactly, and that's why we say .NET is a non-deterministic garbage collection. Just because there are no more references to an object, you cannot guarantee when that object is going to get deleted, because garbage collection only deletes objects when it does a scan and sweep, right? When it finds that there's no more references via memory pressure. Get a whiteboard? Oh my god, I see like a whiteboard behind me, Doc Smari. And I'll just start drawing. Live on stream. Alright guys, let's draw another name. I forgot. Let's draw another name here. Let's do it. And our fourth winner is X-Force P, buddy. Are you out there? X-Force P, please say something in chat. And we'll give you a game. 90 seconds. Diego, our game, since we're a roguelike game, we procedurally and randomly generate our game. So it's different every time you play. Hustlin' Hack, you are in, my friend. You're right up here, buddy. You just gotta talk and chat and you get in. Does defragmentation occur on every garbage collection? Pigeon King, that's, I don't know the answer to that explicitly. I believe it does not. It only defrags when it needs to, right? It's because the defragmentation step can be a slightly unoptimized, or it could be, if it only does it when it needs to, they don't want to defrag every time. Oh, Jetty, maybe. If he can do it live on camera, Jetty, maybe. Maybe even something better than that. I am not Osmender. Our control scheme doesn't really extend well to like a mobile controls. X-Force is not here for games. Alright guys, no problem. Good guy X-Force. We are going to do the reroll train, guys. Good luck everyone. Here we go! New York Locks. New York Locks. So you're out there 90 seconds. Let's hear it, buddy. Let's hear it. 90 seconds. Say something in chat. Hello, hello, Kimakus. Let's see here. The large object heap, everybody. So I talked about Gen 0, Gen 1, and Gen 2, right? .NET, garbage collection. I think everybody probably has a pretty decent idea of what that means now, right? I hopefully everyone understands every time you new and delete an object in .NET, under the hood, what's that going to cause down the line? Now, the large object heap. If you initialize, like I said earlier, if you initialize an object that the data size is 85,000 bytes or larger, it's not going to go to Gen 0. It goes to a special large object heap bucket, and that's where it stays its entire life. The thing about the large object heap is it never defragments. They do not defrag it, so it's a very unoptimized chunk of heap space. You got to be very careful when you're using large objects. And large strings are large objects. Be careful. If you do a file dot read all text and it's a large file, guess where that data is going to live? In the large object heap, right? When I'm down south, hey, the toys, man. Maybe we hang out at the same places. Maybe we hang out at the same places, toys. .NET 4.5, however, guys, in .NET 4.5, they have finally added in a way for us to tell the garbage collection that on the next full collection pass to defrag the large object heap. So it's very cool. There's now a way for us to defrag the large object heap. However, you got to be very careful with it. Defragging the large object heap, if you let it build up for a very long time and then you defrag it, it's going to be extremely slow. You're going to have a very huge GC pause when that's happening. So if they let you do it, know when to do it, though. Uh-oh, toys. Uh-oh. Can you join Best? Of course you can, man. Oh, sorry. I didn't even see the reroll, guys. I got caught up talking because I have a giant ego head. I apologize. Reroll time! King Recycle, are you out there, King? Please say something in chat so that we can give you a game 90 seconds. We're kind of wrapping up, Rock. Rock, we're kind of wrapping up the stream, giving out some raffles for having everyone so cool to hang out while I taught some C# stuff today. This is our little break into stream time. Give you guys a chance to win some games. Games, everybody! I like games. Who doesn't like games, right? I'm going to close some stuff down while we talk as well. Don't need any of this stuff open anymore. Oh, you know, there's one thing I forgot to talk about today, guys. In between rants? That's right, Doc Smari. Castle Crashers, not. I think Phenom Phantom wanted some Castle Crashers. King Recycle. Congratulations, buddy. Congratulations. I'm going to send you a message right now. Give me a second, King. Congrats. I need your email, King. I need your email. So if you can go check your Twitch messages, check both your inbox and your other box, respond to the message I just sent you with your email address. I'll have Steam email you your game. Congratulations. That girl troll is heavily well-armed. I know, Diego. I know. There was one thing I wanted to bring up today that I forgot to bring up, guys. I'm sorry. I'm going to tell you about it right now. Again, this is something new, just added, .NET 4.5. I haven't used it a lot myself. And its uses are going to be very specific for you as well. But in C++, right, we have a way to mark a function as inlined to give a hint to the compiler that, hey, compiler, think about inlining this. And more often than not, it will use your hint and use it. Before .NET 4.5, inlining, we had no way as developers to tell the compiler, that, hey, I want to inline. I want to inline this method. Instead, what it would do is it, based off of the opcodes, the size of the IL, the .NET runtime would decide if it would inline for you or not. You had no control over it. However, now there is a attribute you can add to any method. It's called the method impl attribute, and you give it an enum of method impl options dot aggressive inlining. So you can add an attribute to your method now that tells the compiler that, hey, I really want to inline this, and it will aggressively inline it. Your code is probably going to increase, but your performance might improve. So why we talk about this, and I send out a game to Castle Crashers, I want to try something here. Give me a moment. I want to see if this will work, because why not, guys? We're still streaming. You guys want to see one more test? I'm going to get rid of all of our code that we added. I have some old code for our object allocator stuff. We actually still have our object allocator. I just want to get rid of all this, get back to our baseline, right? Let's try this out. King, I will send you your game here in a minute. Don't you worry. You just hold on. You hold on. I want to aggressively... I'm going to create 2 of these. New. Inline. Right. From a new inline. Method impl. Compiler services. Method impl. What are my options? Sorry, yep. Dot. So you can give, by the way, you can do all type of method options. I can say don't optimize this, prefer signature, do not inline this, right? You can do all types of cool stuff if you've never seen this. Tell this, hey, this is an unmanaged option, all the kind of stuff. But aggressive inlining is what we're talking about right now. I'm wondering if we can get our performance down on our new call even further. Even further. So let's do a quick measure of this, right? We're just going to test not baseline between aggressive inlining and not aggressive inlining. Measure not 5 reps. For int I 0, I less than a huge number. I'm not looking at chat right now, guys. I will get back to that. We want to go to our fast object allocator of objects. Got new, right? We want this. Make sure we have no garbage collection that's going to mess with us. Full collection. All right, so this is inline. And there's our inline, right? Let's see what happens here. Okay, so apparently for this case, and I didn't know if we were going to get a performance boost or not. It looks like we're not getting too much of a performance boost going on here. We can increase the number of iterations we're running here. And I doubt... Okay, so here we can see that, of course, we're going to start seeing a small increase, right? But this is a very small performance boost on average for the number of calls we're making here. And if we went back to measuring our native, right? What was our native, which was just return just new object, right? This was kind of our baseline. If we have from 4, 24, right? So not bad, not bad. You'll get a small like nanoseconds improvement, but you can get better improvement depending on what's going on in that inlining, right? If it has a lot of parameters being passed in, they have to go on the stack and not on the stack. If you're doing a call verts, a lot of call verts, you might get some improvement. All right, let's go back to chat here. Let me get a game out here. I just wanted to show you guys that you can now in 4.5, you can flag the compiler to say aggressively inline if you would like to. Sometimes that will give you a benefit. Sometimes it's going to bloat your code, and you're not going to see any performance out of it. Castle Crashers, let me send this out. And then I'll look at chat. I'm going to draw one more name, guys. I'm going to draw one more name. And we'll see who our last winner of the day is. All right, King Recycle, email sent. Go check your email. Steam should be sending you one. Have fun with that game, dude. Have fun with it, man. Let me see what's going on in chat, if anyone was annoyed by me. In the C++ community, generally accept that the compiler knows best when inline. Absolutely, Dakmari. And even in .NET, the compiler's probably going to know best when to inline. This is just giving you, as a programmer, a little bit more power to give it some more hints, right? String interning. We didn't talk about interning, Pigeon King. If anyone doesn't know, string interning. What is string interning, guys? It's a garbage collection optimization technique. If you intern a string, that string basically goes into a static process-wide list that you can then use throughout your process without creating a new string of that exact same value. So whenever you intern a string, you now basically it goes to a list, right? So every time you create a new string, you can check to say how I want to intern this string. If it's already on the list, you just get back a reference to that static reference, that reference on that static list process-wide. So it's another garbage collection saving technique, Pigeon King. And if you use a lot of strings in your program and those strings don't change, if you have a lot of like constant static type string data, interning is a very nice optimization. Love me some water. I'm gonna try and make a game on Unreal. Nice, nice. Aw, Panda, I like it, man. I like it, Doc Smart. Do inlining function improve performance? Yes and no, sometimes maybe. That's the exact right answer, right? Alright, guys. Last winner of the day. Last winner of the day, guys. Good luck, everyone. Let's see who it is. Here it is. The winner is... Zero Signal. Are you out there, man? Say something in chat 90 seconds. Let's give you a game. Congratulations if you are. I need some water. I need more coffee is what I need. Oh, I can really close a bunch of windows down now. So I hope everybody out there, everyone out there learned something today. I hope so. I know a few people said they did, so that warms my heart. That's why I do this stuff sometimes. Oh my God! Zero Signal's passing, guys! Good guy, Zero Signal. Here we go, guys. The reroll train. It's gonna be... How long is the train gonna be? Let's find out. Next winner is... Stereogram Zero. Are you out there? Chat. Say something. 90 seconds. Let's hear it. The toys. I need some coffee. I'm going to go get a cup of coffee soon. Don't worry. Don't worry about me. Let's hear it. Stereograms. What game would you like, buddy? What game can we give you? I have the same thing, toys. I got one too. That's usually how I drink my coffee at home, man. I love my Keurig. I'm a Keurig fan. Oh my god. You know, I gotta say, this was a good. Oh my god, a second pass stereogram. The train, the choo-choo's going, guys. Choo-choo. Here we go, guys. Third winner up. Hyper. Are you out there, Hyper? Please say something in chat next 90 seconds. You learned why I'm the top dev streamer. Why? I think I got your name right. Why did you learn that? Of course, Illies. What? Don't pollute your coffee by putting stuff in it. Coffee just black, guys. Coffee's delicious. You don't need to pollute it. You don't need to mess with it. Oh my god, Hyper. OMG, Hypes. What's it gonna be, buddy? What game would you like? What game would you like, dude? Hello, my Barak. Hello, man. You just did, not a human being. You guys are too kind out there. Cappuccino's good sometimes, Red Lab. But coffee should be black. Would this code freak out if a Twitch and live code username were the same? No, of course not, Hustlin' Hack. Of course not. What kind of developer do you think I am? What kind of developer, Hustlin' Hack? We had plenty of bugs with my chat when I first added. Oh my god, you want a copy of Galactic Arms Race? Nice. I actually know the developer of this game. So Hyper. This one's easy. I don't need your email address. I have the keys for this locked away in my vault. I'm going to go unlock my vault, find a key for you, make a copy of the key. Give me a second. I'm going to send you a copy of this, buddy. Galactic Arms Race. Hyper, congratulations. Email has been sent. Please go check your Twitch messages, check your inbox and your outbox. It's going to be in one of those two. Get your key. Have fun with your key. That key's done. All right, guys. Like I said, that was our last Steam game raffle. The fun's got to come to an end at some point, right? We can't just raffle for 32 hours straight here. I mean, I guess we could. I think people would get bored, though. And you just playing the thing. Toys, I'd probably like it. I would. Is Torque 2D better than Coco's 2DX? Suicidal, find the one you like the best and just go use it, man. I don't think any engine, in general, I don't think any engine's better or worse than any other engine. That's just how it is, guys. That's just how it is. So what did we add today? Alright, so that's implemented. I'm just making sure I got everything uploaded that needs to be uploaded. I think I do. But Coco's 2DX is a great engine, man. You should check it out. Alright, guys. So like I said, this was the end of the stream. We were just doing a bunch of raffles because you guys are so super duper awesome. And I wanted to give away a few games while still here. So again, I hope everyone out there had fun today. I hope you learned something today. This obviously is not my normal development stream. Normally I'm here developing indie commercial games 7 days a week, but every once in a while we take a break from that. And hopefully I try and impart a little more knowledge than I normally do every day. So hopefully my mission was accomplished. Don't worry, I do more streams like this every once in a while. There will be another one. I just don't know what it'll be yet. And that's it, guys. So hope everyone has an amazing rest of your weekend. Feel free to come on back tomorrow. My weekday schedule starts again tomorrow on Monday. We'll be back working on Ender Station. We're going to be implementing some new features and trying to get the pre-alpha to the alpha stage now. So until then, guys, everyone have a great day. I'll see you next time.